And there's that. Oh, I got it. There we go. All right. And so the lands from which our members and guests are joining us are located on the original lands of Anishinaabe, Cree, OJ Cree, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. So welcome everyone. Our first speaker for the night is Sylvia Graca, who is our long-term serving Spruce Wood Star Party coordinator and also volunteers with many, many events. And please welcome Sylvia Graca to talk about how I built my backyard astronomy or observatory astronomy. Over to you, Sylvia.
Thanks, Dennis. So I'm sharing my screen now, and let's see if I can put it on there. So that should work. And yeah, so welcome everyone to this beginner presentation on how and why I built my own astronomy observatory. And something I thought about first is like, oh yeah, let's think about why not to build an observatory. And something I used to think, which was incorrect, was that, you know, I won't build an observatory in my backyard because, well, I'm in the middle of the city. I have all of these beautiful trees surrounding me. I have barely a sky. I have all these neighbors that, of course, you know, they like to have their lights on, and for no reason sometimes. And so what's the point, right, of going through all that effort to have an observatory when my viewing may not be that good? Well, the reason amateur astronomers might want to do that is because of convenience. I mean, look at how convenient this looks, right? I have all of my favorite things here. I am comfortably sitting in a chair protected inside this little shelter. And look at how it is when you're observing just out in the elements. You try to bring out your smallest telescope, or you try to stuff your pockets with a couple of eyepieces. You're not going to bring all of your favorite things out there, or your biggest telescope either, because who knows, it might cloud over, or it's just too much work to lug everything out of the house. So basically, it's the convenience, and this convenience allows me to look at the sky like so many more times than before. And so here's my usual setup. It's just an AVX mount with an 8-inch SCT. And this is how I used to observe before the observatory. And as you can see, all of these things have to be assembled. So it's not like I can carry this thing outside and plunk it on the ground and start observing. So I have to get the mount first, this big clunky thing that I put scratches on the wall and bang doors with it. You got to put the mount head on it. Then this rod with this heavy weight, and all of these have to be assembled as well. And then my OTA, of course, it's just an 8-inch SCT. And then you got to get your dew shield to make sure you don't fog over. And of course, sometimes I forget to put it on. So then you have to run into the house and get your hair dryer to defog it. And bring out chairs, bring out tables and eyepieces. And of course, I'm never going to bring all of these eyepieces, and they're not mine. They look really nice, but these are just borrowed from the internet. But of course, what you're going to do is bring out as little as possible because, well, it's just so, there's just so much effort to get all of this, right? You got to bring out your power supply. And by the way, this power supply, I got to talk about it because it's just so efficient. It's this small, and it's super light, and I can use this power supply for 3 nights in a row using my go-to mount, and I don't need to recharge it. That's how good it is. And I bought it on Kijiji used. And by the way, everything you're going to see on this presentation is used. So I bought it secondhand, and mostly everything. And this one I had found on Kijiji for $80. And I asked the guy, I said, why are you selling it? Because it was pretty much new. And he just said, well, I don't need it. I thought, well, who doesn't need a power supply? It's something that's useful all the time. And then don't forget your keypad. How many times did I forget my keypad and have to run back into the house? And after you're all set up, you have to align your telescope, right? So you have to align it north. And I don't know if you can tell, but look at what happened here. Okay, this tree, I usually clip it right here. It took me a little longer that season. This was 2 years ago. But look at this, there's clouds. So when I set everything up, it was clear, and the forecast was to be clear all night, but it wasn't. It actually got a little bit cloudy. And so after all of this effort, sometimes I have to lug everything back into the house. What I did this night is I threw a tarp over it all and hoped that it would be clear later. And sure enough, a few hours later, it got clear and I ended up observing that night. But convenience. Amateur astronomers want convenience to be able to observe as many times as you possibly can. So after I decided, okay, I don't care about my light polluted and obstructed backyard, what kind of observatory do I want? And I saw this is the classic dome observatory. And I thought, oh, this would be easy. All I have to do is, well, probably expensive, but somebody will deliver it to my place and I will set it up and fill it up with all of my things and I'm ready to go. But then I realized this is probably not the type of observatory that I want, because you can tell that this one covers half of the sky. It's got little wheels here, so you can roll it around and view different areas of the sky, but I like to see the whole sky. Sometimes I'll just lay on the floor of my observatory with binoculars looking up at the stars. And so I thought, you know what, this kind of observatory won't work for me. It's really nice, but it's not my type of thing. And then a friend of mine said, how about if we build one off the roof of your garage? And I thought, that is a cool idea. I mean, look at how neat this is. The only problem is I thought, you know what, this looks really complicated. And if anything goes wrong, I'll have leaks into the garage and, could really create a disaster. And I thought, well, I want to have something, I think maybe a little bit more simpler to start with and see how it goes. This is the same situation. Somebody built it off their garage. And I love the idea of being high up too. But the problem at my place, if I'm higher up, I'm able to see more lights because, you can see your neighbor's lights and you can see the street lights. So I thought, okay, that one doesn't work for me. And then I saw this one. This one, you build a deck with a pier in the middle and the building has wheels and you roll the building away. But I thought, you know what? No, if I'm going to have a building, I want to be protected by the walls and be cozy inside and not be thinking that there's a bear outside lurking and just waiting to eat me. And then I saw this observatory is called the Doghouse Observatory, and it's Dennis Cisco. You can find this article on Sky and Tell. And I thought, this is so cool. It's so small and it looks like something that I could build. And here the structure stays in one place and the roof rolls off on little wheels, right? Like this. So you roll it off like this. But then I thought, oh, this is perfect for an astrophotographer, but not for me, because as a visual observer, I actually need to get around the whole place. Because, if I need to look at things over here or over here, I need to walk around the whole place. But if you're an astrophotographer, you can set this whole thing up. You can even sit inside and then walk away and the telescope will be able to turn around and do its thing. But yeah, so this one didn't work for me. This one was kind of cool because it's just like a little closet on wheels. But then I thought about our weather here and the snow, and I thought, you know what, I can just imagine the wheels getting all frozen and snowbanks on the deck getting in the way and not being able to move this thing out of the way. So that wasn't right. And this one, also, it's great, I think, for astrophotography, but as a visual observer, you don't really have a place to stand. But look at how cool, if you're into photography only, this is so neat. You can just, very convenient, open it up and close it up and protect it. So I was so overwhelmed by all the different kinds of observatories and how some of them were so complicated. And I thought, oh, will I be able to build something like that? So I thought, okay, you know what? I'm just going to start with an easy idea. I had 6 patio blocks, so I put them down in a good place in the backyard. I decided where it would be good because that's really important. So you can see here's my neighbor's house, and they actually have 5 windows facing my yard. So when they're on, this whole yard is illuminated. But you can tell with my hedge, I actually cut it just the right size. So in the summertime, it protects me from all that light pollution. So you want to pick a place where you're protected from light pollution and you're not too close to objects, of course. Like in my east horizon, I have this huge cottonwood tree. So I don't want to park myself underneath it and then not be able to see anything. And here's my southern horizon. This is that same house with the hedge here cut to cover the windows. And you can see I can actually get a view of the planets, even though they've been laying pretty low this season, as you know. I am able to actually catch them with my telescope, as long as, the chimney isn't going, which, it's not going all the time, so it's pretty good. Okay, so I started off with the easy idea of having those 6 patio blocks. I picked the location, and then I still didn't know what kind of building I was going to have, but I have all this leftover wood. So I laid it down like this all around the thing, and then I cut the 2x4s to the right height that I wanted the walls to be. And the way to figure out the height of the walls is to just set up your telescope the height that you want it. This is how I usually set mine up, at this height. Sit in your chair and figure out where you want that wall to be so that you're not obstructing the telescope view. So that's what I did to figure out the height. And then we built together this box. And this is my Astro dog. She's my company out there. She's always around. And it's 6x5. And of course, have someone that really knows how to build things. That really helps. And Jerry is so good at this. So he helped me get this thing built up. And what we did was measure, of course, because, once we built the structure, it kind of gets wonky and some of the 2x4s are warped a little bit. So we measured in every way possible. And then we put these little braces. So I would hold it in place nice and square, and Jerry would put these temporary braces to make sure that the structure was square. And we also put them across the walls. And then we measured again. And sometimes, we had to unscrew those braces and tweak it a little bit more, but we made sure that it was straight. And once it was, I screwed in the chipboard sheets all around the structure, except for the front, of course, because the front was going to have the doors, which I didn't think about doors, or I didn't find doors until a few months later. So for the first bit, I actually had a tarp here. And here's the roof, which is made with just plywood. And all the plywood, if you probably experienced this, is warped. You can't find like really nice straight plywood. So what we did was put these little pieces of board and straightened out all those warps that it had. And that really straightened out, and it worked out great. The only downside is that, it makes it a little bit heavier, but it's actually totally doable. And you can see here, this is what we decided to do. We put hinges, and so it's such a simple structure. It just opens the roof and closes it. These triangles here are made with the plywood as well. And here is a side view of it. I still need to get these out of here. One day they're going to poke me on the head or something, but it hasn't happened yet. So, and it's been 2 years or more. So yeah, 3 hinges, big ones like this along the side. And I got a little video here. Hopefully you can see it. And that's how easy it works. One person can just close it up, no problem. And here's the telescope. And here's that southern exposure I was showing you, where the planets were sitting just above the hedge. And you can see here I have this triangle. And now if I was to have that triangle on the south end of my observatory, the telescope actually wouldn't clear and I wouldn't be able to see those planets. So what we did is we put little hinges on that triangle. And these are also left over from a project that I was doing with my cupboards. So just reused 3 of those hinges like this. And now you can smoothly just put it down when you need to get down to that southern horizon. And here is a video of how that works. And it looks like it's not that smooth anymore, but it's been 2 years. Maybe I gotta oil it up a little bit. And here's my little buddy. And here's that hedge, which, by the way, once summer comes, it's like a green wall. You can't see any lights from the neighbors. And I am still able to clear that southern horizon. So after building all that, I put these steel sheets on top, which I also found used on Kijiji. Some guy had them left over from his project that he was doing. And we put it in all around the building, actually. And so this will protect the wood from water and wind and all of the kinds of things. And we made sure it has a lip on the edge here so the water runs right off. And this place is bone dry. There's no wind and no rain that gets in there. So it works really well. And here it is with the roof closed. And right here, I put a hook at the front and at the back, because sometimes when it's windy like today, you never know. It could pick up that door and ruin everything. And there's even enough room for Astro Dog right here. And here I am sitting inside the observatory. I built these little shelves as well, and it's so handy. I can put my laptop here, my star charts. I can sketch right from this table. I added extra little shelves like this so I can put my binoculars on it. And another thing, you notice that this, the natural color of the wood is really bright. So what I did last year is I painted the whole inside a navy blue color. And it's so good because I like to observe with bino viewers. So I'm looking through the telescope with two eyes. But sometimes, bino viewers are not the right thing to look at whatever you're looking at, and you need an eyepiece. And I hate blinking with one eye. It just bugs me. So I like to have both eyes open. So now that the inside of the observatory is all navy blue at night, it's really dark inside. So I'm actually able to look like this, look through the eyepiece with this eye open, and it doesn't get distracted by the other items that I would have picked up if the observatory wasn't as dark. And what's cool about this, and you probably experienced this, but I was amazed at how the objects seem to be floating inside the observatory. It's like I'm looking like this, but yeah, it'll be Saturn or Jupiter or whatever, and it's just so nice and clear to have it that way. And yeah, here are the shelves with all of that, and I have lights all around this thing. So as I walk around the whole thing looking at different objects, if I need a light, it's right there. I can just turn them on. I also have a Bluetooth speaker to listen to my space tune or the news or whatever I want to listen to. And different kinds of lights too that are here permanently all the time. And this one is a white light, but I have the cap of a coffee jar that I can it fits just perfect on it. And it's red, of course. So if I need red light, I can just easily do that. I also have these other two lights. And sometimes you don't need red light. So if you're not an astronomer and you're not used to this, using white light will compromise your night vision. So you want to use red light so that it doesn't affect your night vision, and you can see those really subtle details on objects. But if you're looking at the moon and the planets, you actually don't need red light. And so I use like an orangey type of light. And sometimes I use the white light. So if I'm sketching, I don't need to use dim lights. I can just use these brighter type of lights, and it works perfect. Your night vision is not ruined by that. And I also, Abdul, I don't know if you're out there, but one day when I went to pick up, I don't know, RASC stuff, one of those trips that I made to your place, on the way home, I found this little cabinet on the side of the road. Somebody was throwing it out, and I thought, I wonder if it'll fit underneath here. And sure enough, it fit perfectly. So I painted it blue, and I put all of my things in here. I keep my eyepieces though in a container because, like say if I'm done observing in the middle of the night, I'll just leave everything inside the observatory and close it up. But the next day I'll bring them in because, you don't want them out there in the elements either. And they're nicely protected in the house. They don't get too cold. So you bring them in. And this is how comfortable this is. I also have this observing chair. Thanks, Steve. I bought this off of Steve Elstead. It was a good deal. And it was one of the deals that we got at Spruce Woods, by the way. So if you have any items out there that you need to get rid of, any astronomical items, bring them to the Star Party, and you can sell them at the swap table. Anyway, so yeah, this is how comfortable this place is. I even found the carpet on Kijiji, brand new almost, and it's navy blue, and it fit. I never had to cut it. It was perfect. And Astrodog fits right there too. So look at this. This is how I used to observe. Like how, I mean, it was great, but I mean, to what I have now, I look at this and, oh man, the effort that it took, you were in the wind, leaves are flying, and it gets dusty. So yeah, it's just so much nicer now. Another thing I used to think about is like, well, what kind of observatory do I want out there? I might make it look awkward, and then if I want to sell the house. But now that I have it, it's so cute. I really like it actually, and it's my favorite thing in the backyard. I even have this, this is a palette that I cut, and in the summertime it's full of flowers. And these are the doors I ended up finding. So a few months later, I found them on Kijiji as well, or Marketplace, or one of those places, and just cut them to fit. So basically this guy was selling these 2 cedar doors, and they were really tall up to here. So we cut them to fit. I added these two handles, and now I can put a lock there and make sure that it's locked up so your stuff doesn't get stolen in the middle of the night. And I put this little video together to show you how easy it is to operate this observatory. And by the way, this is a video from 3 weeks ago. My yard is a disaster, but it was even worse because it used to have water everywhere here. This was waterfront property. But the cool thing about this little observatory is that I could prop it up on these 2x4s because, you know, why have them sit in the water? So make sure that I took the carpet out before the water came and propped it up, and the water just was underneath it. And once it went away, took the 2x4s out. And yeah, like I said, the place is bone dry inside, and it works out really great. And these doors just have to be closed in the proper sequence because this one also has a big lip on it. And that's to, of course, have the water run off so it doesn't run into the observatory. And there you go. And these are the hooks inside the observatory. So when we have these windstorms, the roof doesn't fly open. I have 2 of them. But the dream, because of course, you know, as you build these things, you just want to make things better and better, would be to have this pier. Because right now, I don't like these legs. These 3 legs are always in my way, I feel. So, I mean, you know, you can get comfortable, but say, you know, once the telescope flips the meridian, you have to move everything over to the side and jump over the legs. And so, yeah, it would be nice to have one of these. And this one's made out of wood, which makes me think it's easy. I don't know, Jerry, are you out there? We should look at this one maybe. And here's the telescope. And I don't know if you can see, but the moon is actually up there. And I didn't need to put down my southern exposure triangle there. So what do I do in my observatory? I do all kinds of things. I observe the sun. The other day, I actually observed the sun, and I've never seen a flare before. I've never seen a prominence come out this far, and that's because it was a flare. This is actually material spewing out of the sun. And what I did is I got my reticle because I couldn't wrap around my head how far out it was, and I wanted to make sure I was accurate. So I finally got to use my reticle for something. And so I put in the sun, which, you know, went right up to this, and then I sketched in the flare with all the materials spewing out. And the sun has been so active lately. I've been looking at the sun so much with HA, but, you know, I should also get my white light filter out because it's got all these amazing sunspots happening and plage areas. And here's another type of sketch that I did. And I mean, you know, sketches don't have to be a pretty thing. And the thing that amazes me about them is that I always discover something new. Like on this one, what I love about this is I was sketching in this little flare, or not flare, prominence. And then I realized that, oh, it's part of this. So you can actually see that this was one of these hoops that went over the limb. And you just wonder, like, what is going on here with these prominences? Like, you want to get an idea of what's happening, and sketching will sort of take you there. This is a different style of sketch that I did, and it's actually white paper with black pencil, but then what I do is I take a picture of it and I invert the colors, and then I add the color orange. So it's actually done in just a matter of a couple of minutes on the phone, and it changes to this color. But look at this prominence. You see these black holes? These were like tunnels going into the prominence, and there's even a little one right here. This one, I really can't figure out what was going on here. And then there's all these areas free of prominence material. So yeah, it just makes you wonder what is happening exactly. I see Daniela's out there. Maybe one day she'll tell us what this prominence was showing us. And there was 2 sunspots on it, and then just a filament squiggling from one to the other. Another thing you can look at is double stars. So you don't need dark skies for this. I didn't know this, but I saw it on the National RASC website that they have a program for double stars. And I think they have like 120 objects that you can observe. I only did a few so far, but it's true. You can actually see the color. Light pollution doesn't affect this kind of thing. And of course, the moon. You don't need dark skies to look at the moon, and the moon is just so amazing. On this day, I was looking at this crater, Eratosthenes, and I thought, what a wonderful crater. It just looks so good, and I decided to sketch it. It took me like over an hour to sketch this crater. And then I thought, you know what? I was gonna pack it in, but then I thought I'm gonna add this little bit of mountains here because it's so pretty on the telescope. So, and sorry about the picture because I took it with my cell phone and it's just not good, but it was so clear on the eyepiece actually. So I start putting in these mountains, and then I was just blown away by what I was looking at. There was so much drama on these mountains. There was so much height here. You can't really appreciate it by this picture, but there was so much height and gullies almost. It almost looked like it was eroded by water, which of course that's not the case, but and there was so much depth to this thing. So yeah, so here's the crater, which is not really something that I'm really happy with, but the memories of this area are just, you know, implanted in my brain. It's just such a beautiful memory to see, you know, and remember how these were really deep crevices were sticking out to me. And here's another sketch. So this is a sketch. You can see the walls here, and then, you know, this part that goes down, and the shadow from these walls. And then there's like a hole on the side wall, and the light is shining in from the sun. And it's like you open the door and the sunlight is just shining in. And so I wrote on my sketch, La Puerta del Sol, the door of the sun. And Jerry saw this and he goes, no, that's Hypatia. Very matter-of-factly, that is what this crater is. It's not the door of the sun. Anyway, all of these little memories, when you sketch something, it just really sticks with you and you remember. So my Cosmic Doghouse Observatory, I just love this thing. And not only because I am able to look at stars, but I discover nature in my backyard that I haven't heard before. Let's see if you can hear this. I don't know if you can hear. Can you hear that sound?
Yes.
There it goes again. Okay, so what a reasonable person would think, why is there a monkey in my backyard? I think. And anyways, of course, what I did was I just closed the little doors of the observatory and sat there with my little astro dog and wondered, what is this creature? And I think Mike Caracas, I texted him about this and he said that it was a barred owl. Now they have so many different calls, and there's the dog barking at it. They have so many different calls that I was just so surprised about this one. And let me show you. That's what a barred owl looks like. During the day, even on rainy days, I'll also go out to my doghouse observatory to sit, and I will do, you know, I will do my reading in there. I'll drink my coffee, and I look at birds. I mean, these birds, for whatever reason, when you're in the observatory, you know, they don't really care about you. They don't really have a high security system, I don't think, because they are singing like right beside me and I can see them and hear them. And this is what I love about this observatory. It's one of my favorite things. And I really don't need to go anywhere because it's all right here in my backyard. So if you have the opportunity to build something like this, it's really easy. And by the way, it cost me $500 total to build this thing. So there you go. If you have any questions, you can unmute yourself and just ask me the question now, or you can email me if you think of something later.
Again, to emphasize, if you got a question, we got a minute or two, go ahead. If you do, or you're not sure, just put your hand up. All right, Sylvia, it looks like, oh wait, let me just double check here in the chat. Just some great presentation, Sylvia, in the chat.
Thank you.
There we go. So if nobody has, I see some hand clapping, everything else, excellent. Thank you very much. Well, Darren's got his hand up. Go ahead, Darren.
Awesome presentation. Thanks, Sylvia. That was really nice. That looks like a lot of fun using that. I was going to ask you, I know you have solar gear. Do you sometimes set up your solar? Not that you have to necessarily, but would you sometimes during the summer months set up your solar kit there?
Yeah, actually, so with the HA telescope, because it's so small and easy to carry, I'm out there even if it's minus 30. But I don't use my observatory for that. I just go outside with my little telescope. But in the summertime, right now, I will use the white light filter more. And I also have a glass filter as well.
Oh, okay. Good to know. Thanks. What breed is your dog? He's cute. He or she is cute as a button there. Reminds me of my little Astro dog I used to have many years ago in Edmonton.
Oh, really? Yeah, it's a Westie Corgi.
Cute little pooch. Really fun.
Yeah, she's really good. I have to watch that the owls don't get her.
For sure. Well, again, thank you very much, Sylvia. So we're going to start our formal portion of the meeting now. And I'm just going to start off with Sylvia because she's going to talk a little bit about Spruce Woods, and then we'll go into the rest of the agenda. So back to you, Sylvia, for Spruce Woods.
Okay. Let me, I guess I should share my screen. Okay, 1 second. There we go. And okay, there we go. Almost there. Okay, everybody. So it's time to start thinking about the Star Party. Yes, I know it's not until September, but it's never too early to start checking those checklists and make sure that you have all your equipment that you want it up and running. Check that you have all your camping gear, because before you know it, summer is over and the Star Party starts. This year, it's going to start on September 1st until the 5th. So you can tell, usually we have 3 nights, but this year we're going to have a 4-night Star Party. And there's nothing special going on that extra day. It's just that the committee, then we don't have to rush around setting up hospitality tents and porta potties and things. So we're going to go a day early. And we thought we'd extend this invitation to anyone that wants to come out a day early as well. So yeah, nothing going on special. So you are welcome to come out a day early if you want to. It's on a Thursday until the Monday because it's a long weekend. And the only thing that we ask is when you get out there, before you park your equipment or your car, is that you get a person from the committee to kind of guide you to where to park. Because of course there's a plan on how to park your vehicles and equipment. So the cool thing that's happening this year is that Spruce Woods Provincial Park is actually officially announcing that they are a dark sky preserve. So it's going to be a really special event. We're going to hold a ceremony and we're going to make sure that we invite everybody that should be there. Like for example, we're going to have people from RASC National. We're going to have the light abatement hero, Rick Husiak from Saskatchewan. He's going to be coming for a few days as well, and he's going to give a special talk about it. And we're going to invite the First Nations. They have a casino very nearby, and they've been on board with the Dark Sky Preserve from the beginning. They could have had, obscene lights going on, but they didn't. They actually got lights that were totally compliant with the dark sky. And I mean, if they hadn't done that, the whole DSP would have been compromised. We're going to invite the Friends of Spruce Woods. It's an organization, a volunteer organization that helps Spruce Woods get the lights. And, they help financially a whole lot with Spruce Woods. So there's going to be lots of special guests. And of course, our very own DSP team, which is led by Tim Kennedy and Sandy Shuchuk. There's many more people that have contributed to this effort, of course, from the Winnipeg RASC. But these two are the ones that really drove the program to, actually happen. And they put in so many hours and days and weeks of work, and they're going to be there. So I'm really happy about that. For registering. So Russell, if you're out there, please post your email address on the chat. And also you can just ask us later and we can share this email address, but you will register with Russell. He's the registrar for this year. So thank you, Russell. So for the people who are new and never been to a Star Party before, I'm just going to quickly go over what is a Star Party. So A star party is where amateur astronomers gather and we exchange ideas. It's a place where you can talk to others about, you know, those galaxies that you've been looking at that appear kind of peculiar. Or, you know, how a star cluster has a weird amount of red stars in it. Who are you going to talk about these things with? So that's what star parties are about, is hanging out with people who are like-minded and are into astronomy. It's a place where we all share a dark sky experience. We all bring our telescopes and we observe together. These are beautiful pictures. I think Ron took these ones. Ron Berard, I hope you're out there. I don't think I saw you, but thank you for sharing these pictures. And these are older pictures. Here we have the hospitality tent. And this is Gail. And actually the hospitality tent is going to have hot chocolate. We're going to have tea and coffee, and Gail is going to bring hot water to the hospitality tent. So you have hot water during the night. So thanks, Gail, for doing that. And by the way, you see this here, this is a fire. We have one fire pit because you're not allowed to have a fire at a star party. But if it clouds over, we have a fire. Now, what happens is, of course, as soon as you bring out a telescope or something like that, it clouds over. You start a fire, it clears up. It seems that that was kind of a pattern that's been happening. Sheila Wishart took this awesome composite. I just love this. This is one of my favorite pictures of spruce woods, and this is what she saw. And look at this. Again, we're having a fire, but it's clear, but it was cloudy. So I think we should adopt this procedure. If it gets cloudy, start a fire, so then we can have clear skies. Thanks, Sheila, for sharing these. And by the way, astrophotographers, if you have pictures of spruce woods like this, please send them to me. We're always looking for pictures. So it's an overnight excursion. So you're going to be out there for 3-4 nights. Make sure that you bring all of your camping gear. And the most important thing is warm clothes. There's nothing that, you know, stops an astronomer on his tracks when you get cold. It can just stop you from doing everything. So get warm clothes, dress in layers, and dress in layers before it gets cold. Don't do it after you are cold already, because it just doesn't seem to work. Bring a good pillow, bring lots of blankets, not just one good one, bring lots of good ones. You want to have a good rest, and red flashlight, of course, because you're not allowed to use white light out there. And bring a book just in case. Food and water, you're responsible for all of those things in your tent. And you set up during the day, just like Sean Caesar did here. And no need to explain why you would do something like this. Basically, you set up and then you just sit waiting in the sun for the stars to come. So what type of equipment do people bring? You don't have to bring any equipment. You can just do naked eye observations. You can bring binoculars, telescopes, big telescopes, and ridiculous big telescopes. I hope somebody brings those, then we can look at them. Brian took this picture. Thanks, Brian Statch, for sharing that one. And how to get to Spruce Woods? Well, the way I go is Highway 2, all the way to Highway 5, and then you just follow the directions into Spruce Woods Provincial Park. You can also take Highway 1. And of course, that depends on where you're coming from. But if you're coming from the city, that's the 2 easiest ways. So why Spruce Woods Park? Well, look at this. Ron took this picture. It's just pristine, dark skies. This is a celestial canopy, as he called it. Beautiful place. And here's our new hospitality tent. And Ron must have been up until really late, because Orion doesn't rise until like 4 in the morning, or maybe even later, to be this high up. We have many cool things to do. We will bring all different kinds of solar telescopes. Here's Chris Keller approving of the whole event. If you like to go paddling, canoeing, or anything, we have the Assiniboine River going right by the observing field. And there's horses. If you like horseback riding, there's a stable nearby. There is this really cool desert-like area. It's called Spirit Sands, and hiking trails everywhere. And you even have a beach. So if it's warm in September, you can go for a swim. There's a lot of different creatures at Spruce Woods. Some of them are friendly, and some of them you should really watch out, could be dangerous. And we also go biking. So these are just unplanned events. You know, if it's nice out, we'll go biking in a group. There's so many trails to explore. And here's the observing field. So when you come into the observing field, you come from over here like this, through the trees, and there's a place behind the trees called the winter use area. And then you just keep going and following the signs. And you basically park your tent and your car right beside your telescope. So when you're done observing, you just crawl into your tent and it's all over. And this cut field right here, it's a trail leading you to the most popular event of the whole weekend, which is Jerry Smerchansky's Sky Tour. And you can see here the laser beam where Jerry is pointing to the various objects in the sky. This Sky Tour can go on for hours. So, I mean, you don't have to stay, of course, but I mean, it's just amazing to the knowledge that Jerry has of the sky, and all you got to do is bring out a nice, comfortable lounger, blanket. Remember to always dress extremely warm. You think that it's extreme, but really bring your winter clothes to this thing. Bring your binoculars so you can follow along with Jerry. And you'll really enjoy this. On Saturday afternoon, we'll have a telescope tour. So if you have a setup, please, that you want to show us, please set it up. And this year, Cliff Levy will be taking us around the field and showing us everybody's telescope setups. And everybody asks questions, and you can show us what your tricks are. We also have the swap table that I mentioned earlier. So if you have any items that you can sell or trade, bring them to the swap table. This year it's going to be Michelle Paquette that's going to be leading the swap table right after the telescope tour. And then, of course, we have all the special talks going on. This year, we're going to have Rick Husiak giving a talk. We're going to have somebody from National, from the DSP. And we're actually going to have our very own Gail Weiss giving us a presentation of all the RASC programs that she's completed. I'm so excited to hear about this, Gail. See what you've been up to under the stars. And now, we used to have a banquet every year, but this year we're again not going to have the banquet because I didn't know what was going on with COVID and just thinking of planning and people, I don't want to turn this into a super spreader event. So what we'll do is we decided to have some tables set up close to the hospitality tent, right by the hospitality tent. And if anybody wants to, have supper together in a group, you're welcome to come. It'll be open probably from like 6 to 7 or 5 to 7 or something like that. And you can just bring your food to the area that we're going to set up. And if anyone has a barbecue, that would be great if you could bring it to the area and then we can all share it. So at least it'll be a good opportunity for us to hang out and talk. And here's the hospitality tent. And Brian took this picture, I think, with the rainbow. It's so cool. We're going to have maybe, I'm not sure yet, but we might have a telescope clinic. So if you have a sick telescope or a sick set of binoculars, bring them to the star party and we will look at them and try to fix them up for you. And here's one of the clinics. We haven't had one in a few years, so I'm sure there's a few sick ones out there that need attention. Also, sometimes we get cloudy nights or rainy nights, and there's a cabin available at the park really close by. And we can have presentations and just a place to gather and talk in a nice, dry and warm place. And again, another fire, and I see that there are stars out there. So yes, we have one fire pit. Remember, no fires out there unless it's cloudy, and then this happens. Ooh, and another one. So star party etiquette. One of the most important things people told me that I have to make sure that happens is that nobody uses white light or has blue lights. I don't know if you noticed, but some of the security lights in vehicles flash blue lights. So make sure you don't have one of those. And if you do, that you cover it up because it's really distracting. And I mean, people travel 2 hours to go to a dark sky preserve. So it'll be a shame if white light is out there. Last year too, there was a vehicle that had this tiny blue light on top of it. And you could only see it from certain places, right? But one area of the field could see this blue light. So if you can't shut it off or figure out how to shut it off, throw a blanket over it. That's been our solution for the past few years. And if you don't, you have to be, you're just in trouble because we have Astro Diablo. This is another picture by Ron. He's going to be appearing. As soon as white light or blue lights or anything comes up, Astro Diablo will be on your butt. So just a warning. And on the Monday morning, because it's a long weekend, we're going to have the continental breakfast. So basically, we're just going to have cinnamon buns and banana bread and things like that, coffee, hot water. And right afterwards, we do a group picture. And this is the group picture from last year. If you would like to volunteer and help us out, please let me know, because we're always happy to accept help, even if it's, bringing an extra loaf of banana bread or something to share for the continental breakfast. Anything you can think of, let us know. We'd be happy to welcome you into the group. And I want to take this opportunity too to thank the Spruce Woods Committee for all their help in planning. We are almost done the planning for the Star Party. So I want to thank Russell and Gail, Michelle, and Cliff for all of their help. Also, Brian is going to be help us, and Damien. So thank you so much. And again, if you have any questions, unmute yourself and ask me now, or you can just send me an email and we can talk about that, about anything that you might have. And that's it. So I'll pass it over back to Dennis.
Thanks, Sylvia. So very quickly, is there any questions? I answered the one question that was in chat about parking for the non-campers. And in case you didn't see it in the chat, that's yes, there's parking. You just park outside the gate and walk in and then walk out at the end of the night. So not seeing any questions. All right, well then it's my turn to share the screen. There we go. Now I can see my screen. I have to move the pictures out of the way. So again, good evening, everyone. So tonight for the rest of the meeting, I'll be doing out some announcements. We talk about the different volunteer positions that are available. Tonight, Brian Stack will be talking about what's up, and what's new is Dr. Danielle Pahoud. Then we'll have a break. We get a chance to talk for a little bit. And then our main presentation tonight is Darren Hennig, who is talking about dark nebulae. Welcome to the dark side. And then we have a virtual get together afterwards. So things to be aware of, bylaws expect to present in August, September. There will probably be a formal announcement go out next month, I suspect, to give lots of notice to the membership. Our Mars geology trip that we were trying to coordinate, unfortunately, our presenter who was going to do it is booked up totally. He's with COVID over, there's all sorts of events and things that he's either running or has to attend. So I have talked to him, and we're going to try and see if we can put something together for next summer, maybe after, well, everybody gets all their COVID travels out of the way. So we are looking for volunteers for meeting presenters. So as you saw tonight, we had Sylvia. You can do a beginner session on something you like, or any other topic that's appropriate for the society. Our Loner Scope coordinator is Mike Krakus. Now that we're able to get out and about, we highly recommend that if you want to try for the new members out different scopes, we have both types of scopes and a solar scope that you can borrow. And we recommend all you do is you contact Mike Krakus, and that information is on the website. Our binocular interest group is still going quite strong. Darren Hennig runs that tonight, and he is the presenter later tonight. And again, if you're interested in joining that, just look on the website and you'll find details on how to get a hold of Darren. We are hopeful that the June meeting will be in person. The challenge we've got right now is we're not sure where. We're running into some major issues in the sense with the U of M. Is that we cannot bring any of our own food or goodies in. It all has to be catered. So we are looking at alternate locations as a council. Well, once we know where we might go, we'll be able to announce that. But we are leaning towards the June meeting being in person potentially. Can't confirm it yet because we don't have an actual spot. The good news is that in July, that is our get together and barbecue out at Glenlee. So that's the plan. Just keep that in mind, that the July meeting will be out at Glenlee with a barbecue. Yay. Public events. So a couple things. We had lots of public events going on this past weekend. It was really nice for Astronomy Day. Thanks to the Manitoba Museum. They invited RASC to come and set up our scopes outside while they did a First Friday event. It was quite nice. We had several volunteers there with their scopes, and for the first hour while we were looking at the sun, it was nice, and then it clouded over, and unfortunately that was the end of that viewing and that. But there was a huge amount of interest, and potentially we will continue this event with the planetarium and the Manitoba Museum. So if you're interested in helping out, even if you don't have a scope, it'll be nice to be there, because then you can talk to people and just guide them or fill them in on what the RASC Winnipeg does. Peace Gardens has talked to us about having an event on August 26th. And this event is recognition of, I believe it's the 90th anniversary. And what they're looking for is they'll have a dinner under the stars, potentially have a little speaker, and have one of us do a speak, like talk about astronomy and whatever, and then with some night sky observing afterwards. It won't be very dark at the time, but they are looking forward to that, and we're still in the process of working out all the details. So if you have an interest in participating in this, please let us know so we can start putting together a little bit of an agenda of what we can do. Fort White Alive, we've done something very similar there a few times in the past as well. So for those that have been around for a while, it would be an event. Probably, I think it's going to be an event similar to that. Astronomy Day, I already talked about. We are getting quite a bit of requests for outreach at schools. Some of them are for presentations in the classroom, and also for presentations, come over in the evening, set up a scope in the schoolyard or in a park nearby. If you're interested in volunteering for any of these, if you could let council know so we can make a list of people, and we'll always ask for volunteers, but if we've got some people who have an interest in doing this, that would be really good, and we can let you know as soon as we have a volunteer or a request for volunteers. Glen Lee and the flood forecast. The flood has happened. If you haven't seen pictures, the observatory is surrounded, and it's up to the base on the warm room, but it's not very high. So it's being monitored. So obviously Glen Lee is closed for the time being. We had a beautiful discussion already about Sprucewood Star Party by Sylvia. Would like to announce tonight, we have our 2021 Outstanding Achievement Award is Trevor Bryant. I would love to show the big plaque. However, it's at the observatory. And for our 2021 Outstanding Service Award, we like to thank Gord Tulloch. And our longtime member, this is something new. We're trying to recognize some members because most of us probably weren't even aware of this. Norman Howe, who is still an active member and still member in good standing since 1967. So I know I'm sure he's not on tonight, but it's just good to recognize those who have been a member for a very long time with the RASC Winnipeg Center. So the volunteer opportunities that we have a meeting coordinator, volunteer coordinator, spring star party chair, explore the universe coordinator, webmaster, a mentor coordinator, meeting presenters, people who may be interested in being on the finance committee, as well as the observatory committee. And every month we try to talk a little bit about each of these positions. So the one we're going to talk about a little bit is the Spring Star Party Coordinator, which is kind of good because Sylvia has just given you a really good example of what a Star Party Coordinator does. So Sylvia has a team of people to coordinate. So that position coordinates volunteers for a spring event, similar to Sprucewood Star Party. We've definitely had interest from the members in a spring party, but obviously it's going to be a different format because of the time of year and everything else. So again, the Spring Star Party Coordinator works with a group of volunteers to find the location and develop a program for 2 days and evenings is pretty much what it would look like. And they also work with the council, and the council's there to support them for recruiting volunteers and then reporting back after the event. So if it's something you think you might like to do, please let us know. And I'm just going to take a quick check in the chat for a second. Nothing there. As I mentioned, anything going on at Glenlee has now been shut down. In case you're interested, the water is just up to here. So as what it appears like in the videos, or not the videos, the pictures I've seen recently. So next I would like to introduce Brian Stack, who's going to talk about what's up. And I will stop sharing. Please welcome Brian Stack.
Hi, everyone. Thank you, Dennis. Let's see what's up for May 2022. And there we go. And F5. There we go. Okay, so what's up for May 2022? Let's find out. Let's start off with the planets. Unfortunately, most of the planets are going to be visible during the day, especially in the pre-dawn. Mercury is going to be fading pretty fast, so we won't be able to see that. But Saturn will start to slow down, especially in the next month. So what's happening in May? Not much. I will mention a little bit about the total lunar eclipse that's happening this Sunday. I've been monitoring the weather for quite a bit, but one model shows it's going to be clear. Another model kind of shows it might be cloudy. So just hope for the best. For the most part of it, much of the planets will hook up with the moon, but that would be either in the pre-dawn or during the day. So let's find out a little bit more. So this is going to happen tomorrow. As you can see, the planet is still pretty lined up. I'm going to have to move this around. All right, let's go into my studio mode here. All right, as you can see, most of the planets are going to line up. That's starting tomorrow. This is happening today, but unfortunately it was cloudy. I hope you guys can see that this is Venus, this is Jupiter, and this is Mars, and we do have Saturn here. This is what's happening during the day, and this is around 12 noon. Like I said, most of them are going to be visible during the day and in the pre-dawn. Saturn is already starting to set. Okay, so what's happening on the 22nd? You can see Saturn's going to be, well, 3 degrees. Oops, I went a little too far. I can't go back. Okay, so as I mentioned before, this is what's going to happen on the 24th. I just want to move this, kind of move this. Oh, thank you. Yes, sorry. All right. So on the 24th, we have Jupiter and Mars are being pretty close. We do have Neptune, if you're into Neptune. And of course, this happening pretty early in the pre-dawn, especially just before 4 o'clock in the morning. So if you're either staying up or getting up quite early, hopefully you'll be able to see this events. The next one, as I mentioned, on May the 24th, Mars will be 3 degrees north of the moon, but this is going to happen pretty much around just before 2 o'clock. This is Jupiter. This is going to be Mars, which is going to be 3 degrees from the moon right here, just 3 degrees north of the moon. Okay, next screen. Okay, this is where Mars is going to be just less than a degree from Jupiter. Saturn's going to be pretty up. Again, this is around 4 o'clock in the morning. So this is less than 1 degree. We have Neptune, and of course, Saturn is up here. So that would be interesting to see. That's on the May 29th. So that's pretty much at the end of the month. Next, a little bit about the Milky Way. I picked May the 22nd for a reason, because I'm hoping over the long weekend, I'm going to head out and maybe do some shots of the Milky Way with someone. Unfortunately, it starts off pretty low early in the evening. It's not the best of the Milky Way because we just have the end, and here's the core right here. It will rise up high enough, but again, that's going to be around 4 o'clock in the morning. It'll be almost directly overhead, but I'm hoping that over the long weekend, I'll get out there and do some photography. Next, I have to mention this because again, I'm monitoring this every month. As you can see, that the solar activity is on the rise. I'm going to have to move this around here. The predicted values for April was 37, and for the actual value was 84. So definitely it's on the rise. It's going to be kind of interesting to see what's going to happen in the next year. So again, I'm going to keep monitoring this. So what does that mean? Well, there'll be more surface details that's going to happen, and as well, maybe some aurora for you guys. All right, now I'll talk a little bit about the total lunar eclipse that's happening this Sunday right after sunset. Unfortunately, it's begun already. It's going to be below the horizon, but right after sunset, it'll be dark enough to see the start of the eclipse, which is going to be just around 9:30. Hopefully, we have some clear skies. Again, I'm hoping to be out there. I'm going to do some practice shots of the totality of the Milky Way, and that will be around 10:30. But we can only hope that it's going to be a clear sky. Now, unfortunately, at the start of the eclipse, it's going to be pretty low in the sky, as you can see here. So it'll move up a little bit here, and it's only going to be 13 degrees above the horizon. So at around 11:11 a.m. or p.m., sorry, this is the totality of the Milky Way. Again, it's only going to be 13 degrees above the horizon. Around just before it actually ends, before 2 o'clock, we'll get up to here a little higher, but the weather-wise, it's going to get pretty cold. At 11 o'clock, it's going to be around 10 degrees, so it'll still be pretty warm, but at the end, it's going to be close to 0. Now what do we have for the forecast? I've been monitoring again, like I said, the forecast already. Last week, Jay mentioned that about 2 models going to show whether it might snow or it might not, but the bottom line is it's going to be cloudy. That was the model a week ago. So as we can see here, Monday or on Sunday around 1 a.m., it's going to drop to below 0. Again, it's going to happen on Tuesday in the morning, and again, Thursday evening around 12 a.m. Again, it's going to get pretty cold. I don't know why it's already May here, but almost June. Now, as for the cloud coverage that we have here, again, this part here, which is the eclipse right here, this keeps changing. So this is supposed to be at 7 o'clock p.m. And it's supposed to be clear skies up to this, according to this model here. But again, this part of it keeps changing every single time. As you probably noticed that we did get a little bit of rain this Friday, a little bit of Thursday, and then we expect some more rain this coming Thursday. So I'm hoping for the best that it's going to be clear Sunday night, because I did book off Monday, so I'm hoping for the lunar eclipse. So that's it for what's up in May 2022. Thank you.
Does anybody have any questions for Brian? All right. So what's new? I will introduce Dr. Danielle Pahoud, and Danielle, you're up.
Hi. Can you hear me?
I can hear you.
Oh, wonderful. Okay, let me just, sorry, I'm reorganizing my screens a little bit. Share screen. Good. Okay, can everybody see my slides?
Yes, we can.
Okay, wonderful. All right. So I have 2 quick topics for what's new this month. The first big one is yesterday's observation by the Event Horizon Telescope of Sagittarius A star, shown here in a composite image, where Sagittarius A star in radio wavelengths is in this inset, and then we have infrared and X-ray observations in the other colors here to give it some kind of galactic context. And so I'll be quoting results from a paper titled Sagittarius A star, NASA telescopes support Event Horizon Telescope in studying Milky Way's black hole. And this is a NASA press release. And so just to give you a little more details about this image, everything in, can you see my cursor? Yeah, okay, great. Everything in this kind of cool shade of blue is Chandra data, and it depicts hot gas from mostly really hot young stars that are formed at the center of our Milky Way, center of our galaxy, center of the Milky Way. In orange, here we have infrared observations of stars. And then in purple, we have Hubble observations. So both the stars and this purple are Hubble observations. And so the kind of warm purple color is cool gas. And then we have the Radio Event Horizon Telescope image here. And then in terms of size scales, this image here is 7 light years across. And the inset here is much, much smaller. And so this is 10 light minutes across. So these are just some of the size scales. So this is this resolution to be able to see a donut on the moon, to give you some context of the resolution that's needed to achieve this. Okay, so the black hole at the center of our galaxy is about 27,000 light years away, or about 8 kiloparsecs. And a detailed image like this allows us to see both the physics of what's happening very close to the star, or to the black hole, sorry, and to give a larger context for some of the dynamics of the gas and dust. And so such a detailed image allows for careful comparison with models that incorporate general relativity, effects that come from whether or not the black hole and the gas surrounding it are magnetized or not, and can incorporate predictions based on models for how much light should be emitted in the different portions of the electromagnetic spectrum. And so if a particular model predicts 3 times as much light in the infrared versus the radio, for example, you can then test that model with these multi-wavelength observations. And so as a really fun spoiler, none of the models match the data perfectly, which means that we have to tweak the models, which is great. And so some of the things that we know, or that we've discovered with these most recent observations, is that we indeed have a picture of a black hole that may look familiar to you. And so there was an image of the black hole in the galaxy M87 from a few years ago that was done by the Event Horizon Telescope. And I'll be doing a side-by-side comparison next. But what we see is a ring of glowing gas here. And so this is a hot accretion disk. And we have a shadow at the center, which is light being deflected around the event horizon of the black hole. And so we had a lot of really good physics reasons to suspect that the octave center of the Milky Way is a black hole, but this is our first direct observation of it. So this is overwhelming evidence that Sagittarius A star is indeed a black hole. And the observations of the size of this ring agree with predictions from Einstein's theory of general relativity. So this is a comparison of the 2 Einstein rings. And so there are some differences in terms of distribution of where the bright patches are, but they're both rings with a dark center. And what's remarkable about these 2 similarities, or what's important to note, is that on small scales, both these black holes look very similar, despite Sagittarius A star, so the black hole in our galaxy, being more than 1,000 times less massive than the black hole at the center of M87. So these are black holes with vastly different masses, but they still have the same structure. They also exist in very different galaxies. And so our galaxy is a disk or a spiral galaxy, and M87 is a giant elliptical galaxy. And so despite these galaxies being so different, the central black hole is very similar. And so this suggests that Einstein's theory of general relativity is robust and dominates the physics of the event horizon in the disk. So it dominates the physics of what's very close to the black hole. And then on larger scales, as we kind of zoom out, the black holes look different, which means that the environment plays an important role. Another interesting feature is because Sagittarius A star is closer to us and is so much smaller, the material that's the event horizon itself is smaller, which means that so the material for both this black hole and the black hole in M87 is traveling at relativistic speeds. The material is traveling at relativistic speeds, but because the distances around the event horizon are so much smaller for Sagittarius A star, we can actually see the positional differences. And so we have essentially some time resolution in these multiple images. And so in the image that I showed you before, it was kind of this average stacked image. And so here, this is the average stacked image. And then these 4 images down here, the Event Horizon Telescope collaboration took all of their images and kind of sorted them into 4 different types. And so here the histograms at the bottom show kind of the representation of the average of all of the images in that type. And then the colored bar on the histogram tells you which one is being represented and how many there are relative to the total distribution. And so this allows us to study time dependence in the material right around the black hole, which is really interesting.
Danielle, there's a question in the chat.
Oh no. Okay.
Why the 3 bright spots?
That's a really good question. Michelle?
Yes.
Yeah. I don't have a good answer for you.
Well, I know in M87, one is due to Doppler beaming, but yeah, so I know the 2 spots, but I'm not sure why there's the 3, but you said there's time information there, so it could just be an overlap because one of the diagrams shows 2 spots, so it's consistent, so. Yeah. Anyway.
This one? Yeah, I'm not sure. I'm not sure.
Yeah. Well, if I'd like to see the article, so maybe if you could fire it off.
I have them open in some of my many tabs, so I can link them in the chat when I'm done.
Okay, cool.
Yeah. There's AppJ has a special issue, which I pulled from, and that's where this figure is from. And so these are, so because the magnetic field is hypothesized to play an important role, there are simulations that include gas, which is shown in these green and orange configurations. And the white lines here are magnetic field. And so you can use essentially magnetohydrodynamic simulations like we do for the solar wind, but around black holes. It's relativistic, but you can make models and then based on how the material is distributed, transfer that to a radiative model, which is going to tell you how much light is emitted. And so we can compare the observations with the models. And what this tells us is that the magnetic field around, sorry, there's a typo here, around Sagittarius A star is quite strong. So the magnetic field at the center of our galaxy is strong. And the angle between the line of sight, so the line connecting the black hole to us observers on Earth, and the black hole spin axis is small. And so it's probably offset by 30 degrees or less, which means that we're essentially staring down kind of this magnetic beam. So we're looking down on our black hole, which is actually a similar orientation to what we've seen for M87. And so the advantage to having multiple wavelengths is that we can observe the process of accretion and gas dynamics at the center of the galaxy. And so accretion disk physics is a fundamental process in physics. So we know that it happens around black holes, but it also happens in star formation and planet formation. And so being able to observe it at all of these different scales really allows us to test different theories. And then Chandra data, so the X-ray data here in blue, will tell us how much material is captured by the black hole from nearby stars. And so one of the goals of the Event Horizon Telescope in looking at Sagittarius A star was to have joint observations to catch X-ray flares. And so Chandra observes X-ray flares in this region about once a day, roughly. And so flares are thought to result from magnetic reconnection, so a process similar to what causes flares on the sun, but at much, much higher energies. And so if we observe them with Chandra and with the Event Horizon Telescope, we can start to kind of pin down the process of what creates them. And so there have been flares of different intensity or different brightness observed with Chandra and Swift. And so that's a fainter one. And then Chandra, sorry, I'm just gonna finish my sentence, Darren. Chandra and New Star, and that was a brighter flare. And then with the brighter flare, the Event Horizon Telescope observed in millimeter wavelength intensity. There was an intensity change and a variability change in the few hours immediately after the X-ray flare. So that suggests some connection between flares in the X-ray and emission in the radio. Okay, Darren, go ahead.
Yeah, thanks, Danielle. Neat talk so far. I was going to say it's kind of interesting because you have two galaxies that are compared here. And in this case, we've got a spiral galaxy that has, like ours. I mean, I noticed that our line of sight is almost dead on to the axis of rotation here. It'll be very interesting to see as they investigate other galaxies that they know have active black holes in their center, which they think most do, of course, to see what the relationship between the, I guess you could call it the main axis of spin for the galaxy versus the black hole. And that should be very interesting. I'm kind of curious about that because you'd expect it to be more flat given that our galaxy is spinning around this whole thing, right? Although I guess this has to do with the matter nearby, right?
Yeah. And perhaps I'm trying, like, the history of the evolution of the black hole and what's been absorbed or to create it or to increase its mass. But I think that'll be really interesting. I have another question. Will the James Webb give us further insights on Sagittarius star? I suspect so. I'm a little biased, but I don't know. I mean, so it'll give us infrared data, which is what some of the Hubble images, but it'll do so at a much higher resolution. So I think it'll be really interesting. Yeah, great questions. Yeah, okay, so with these joint observations at multiple wavelengths, we're able to see contemporaneous observations with the Event Horizon Telescope and Chandra, and so it may allow for the identification of the source mechanism of these flares. And then just real quick, because I couldn't not include it, the James Webb Space Telescope has sent back some new photos. So here we have a section of the Large Magellanic Cloud. This is an image from the Spitzer IRAC 8 micron telescope. So these are the same region. And this is an image from the Webb telescope, the 7.7 micron. And so the increase in resolution is just incredible. So all of the extra stars, you can see the structure and the filamentation in these bands. So it's just exciting times to be an astronomer. And that's all I had. So thank you very much, everyone. Any questions?
Thank you very much, Danielle. Does anybody have any other questions before we move on?
Hi, this is Jim Church.
Hi, Jim.
Hi, Danielle. I hope it's going well with your observational astronomy.
Yeah, thanks, Jim. If it's not a question, maybe we take it to the chat. What do you think?
Okay, what it is I was wondering, looking at the M87 and our Sagittarius A, the black holes, would that ring be due to the plasma being influenced by magnetic fields, by thought, just like the other fellow earlier? And is there like synchrotron magnetic force field going on?
Yeah, there's a really good chance that synchrotron is happening. Synchrotron emission is happening. Yeah, and synchrotron emission, for those of you that are not familiar with it, is electrons that are accelerated around a magnetic field, and they're doing so at speeds that are relativistic. And so as, in the same way that when you take a corner way too fast, the act of turning is an acceleration. And so electrons are accelerating as they orbit magnetic field lines, and so they emit synchrotron radiation when they orbit.
Something always fascinated me with magnetic field anyway, but with these black holes, well, boy, talk about a mega size.
Yeah, it's interesting. It's interesting that they're so similar on such different scales.
But you're right that it was quite similar to the one in the first Event Horizon Telescope 2019, was it? The
M87? Yeah.
Yeah, M87. And so here you got the Webb and the Spitzer. Wow. Star formation.
they'll be looking for it. I don't, right now they're still kind of making sure all the instruments are working and they're testing things. So we don't have any science results back yet.
Oh, okay. Thanks, Danielle.
Thanks, Jim.
All right. I don't see any other questions, so we're going to take a 10-minute break. Everybody that's on can chat, catch up for a bit, and then we'll come back for our main presentation, Darren Haig. So go ahead, everybody can unmute and chat, and we'll see what everybody's been up to. Because we're going to go into our evening presentation. All right.
Except for me, I guess.
That's yeah. So I'd like to introduce Darren Henning, who is our doing our presentation tonight. And Darren, over to you.
Well, thank you, Dennis. Let me just share my screen here and get the presentation rolling here. Hopefully everybody can see this in a few seconds, and I'll just maximize it up here for everybody. I'm just going to minimize my screen so I can see what I'm talking about here. So thanks for joining us tonight, everybody. Looks like we have a really good turnout. Lots of people and lots of new members as well. This is an interesting topic, I think, and it kind of ties into a lot of what we're starting to see with exoplanets and so on. I'll kind of take us through a varied path here tonight. And some of the subtopics that I touch on could be talks on their own right. And I know Jerry's done some in the past as well on this. So we're going to take an interesting journey. So about the last third will be actually how to see these things and what you need to do. So bear with me here. So there's 5 types of nebulas that are understood in the night sky, and we're going to be talking about dark ones tonight. And these are often affiliated with the reflection and emission nebula as well. So they're not always isolated, parts of the galaxy. They will be affiliated with other features in some cases, and we'll talk about why that is down the road here. These are 2 of the more famous ones, and of course, the Horsehead Nebula is probably the most well-known amongst most people, and you can see how you've got this dark occluding matter in front of an emission nebula. So this is what we're talking about tonight, but there are areas that don't have necessarily nebulosity surrounding them, and this makes them a really interesting challenge. Of course, when I talked with my title, the dark side, I have to, tongue in cheek say, we have to bring in Star Wars here once in a while. So I hope you guys will enjoy that part of it once in a while. I'll have a little break with a few cute slides in here. And Master Yoda is warning you, so I hope you'll enjoy this one. Be careful; it's addictive. So when we look at the summer Milky Way as an example, and I will feature mostly the late spring through early fall Milky Way for the most part tonight when we talk about what to look for. Primarily for 2 reasons. One, it allows people to really enjoy the view, and the weather is a lot more amenable usually. And we have seen some fantastic. I know Sylvia mentioned Jerry's fantastic binocular talk, and he covers a lot of this as well in his binocular talk as well. But the summer Milky Way in the northern hemisphere has a lot of really interesting substructure. Usually we're looking at nebulosity, and this is kind of the inverse of it. So hopefully you'll enjoy the path we take tonight. But before I get into that, I just want to kind of look at where we have gone as a species, understanding our galaxy, because these dark nebulae are intimately connected with the inner workings of our galaxy and star formation and so on. The ancient Aborigines, as an example, besides looking at star patterns, and usually we talk about constellations being star patterns in the sky, and we're most familiar with that. A lot of cultures also looked at these dark smudges across this band of stars, well, that we know as our galaxy now, that were also featured prominently, and we looked at familiar things that we were that were in our surrounding area. So as an example, this emu here in the Aboriginal lore, you have, you know, a good extent of the southern Milky Way. And of course, you have Crooks and the southern coal sack forming the head. And I'll have another slide later, high resolution ESO photo, and you can actually see the feather-like regions that you could easily see where somebody could, you know, see a bird of some form. And of course, the Aborigines saw an emu in this region of the sky. Very interesting. But of course, the Incas and Mayans, of course, too, had their own mythology, as well as the Incas were known as, you know, primitive astronomers in Mesoamerica, and actually quite advanced in some ways. And they called this Mayu, or the Celestial River. And of course, all these dark markings, even though we see similar features to the Aboriginal culture, they saw llama, fox, toad, snake. So you can see, you know, being in a jungle environment, of course, they would recognize shapes that they were familiar with. And this is a common theme throughout a lot of early human and even Aboriginal human cultures. So this is not isolated to just strictly one group. And of course, we're a third of a global way technically here, and very interesting things. And you can see the eyes of the llama here are Alpha Centauri and Beta Centauri there. You can see the llama featured there with it. I know it's not the best image there, but I just thought this is a very interesting plate that was taken from a picture in, I think, Peru. So when we look at the Milky Way, this is a reasonably high resolution image. Of course, in the Northern Hemisphere, we see Cygnus through Sagittarius. And you can see here, even in this image, it's replete with all sorts of smudges and gaps in the celestial tapestry, as it were. And this is what we're talking about tonight. Now, if I flip over to the other side here, going into the Southern Hemisphere, Sagittarius to Crooks, you can see now that emu quite prominently, and it's kind of interesting. It's no wonder why, especially in an early culture with no light pollution and beautiful skies. I'm jealous. I mean, I can imagine, you know, even several thousand years ago, it must have just been awe-inspiring knowing what we know now. You can easily see this kind of a structure here. So this is what we're talking about tonight. And there's lots of interesting things here that a lot of people, even when they're doing wide field astrophotography, may not even realize. I mean, they'll see the Great Rift and so on, but there's a lot of other substructure that they may not even realize they're looking at. Of course, it's not isolated strictly to, you know, the ancient cultures in Mesoamerica and Australasia. But we also have Central Asian epics as well. And this is one Sumerian and Babylonian epics. They talk about the Milky Way being created by the severed tail of a primeval saltwater dragoness named Tiamat. And of course, whether you think of it as milk or brine, it was a way to explain what they were seeing in the sky. And it was intimately connected with a lot of ancient cultures, origin stories and understanding of the creation of the universe and so on. I'll just leave this up for just a second or two more, because over the millennia, we started getting into the ancient Greeks. And of course, we're most familiar with Greek mythology here in the Western cultures that we, a lot of us come from. And of course, one of the cultures, one of the wonderful mythologies is Zeus placing his son born of a mortal woman by the name of Heracles. He actually, and I think Jerry talked about this a while back too, you know, more colorfully than I'm doing, of course. He does a great job. He basically placed on Hera's breast, Hera being his wife, this young infant. And of course, she woke up and startled. She pulled the infant away. And of course, the milk spewed out over the heavens. And now we have the galaxy. Very cute story. But it featured very prominently and shaped the opinions of many civilizations until more recent times. And it built on even ancient Egyptian myths and so on too. But of course, like I say, this historical, and you could almost do a whole talk on it on its own right. And I just want to brush very quickly through it. The name Milky Way, though, it's really interesting. I mean, it comes from Galaxias Kyklos, which means Milky Circle. And this is how our galaxy got its name. And of course, even the term galaxy comes from the root words galaxias, meaning milk. And so this is how we get the name for our, what we now call a galaxy, which we know as a collection of stars. So it's really interesting historically how we've gone down a certain path here. And the structure of the galaxy is intimately related to these dark nebulae features, like I say. Of course, the Great Rift story, I remember Jerry several years back talking about Phaeton stealing Helios, the sun god's chariot, and he had a very colorful way of putting it. Basically, like all young men, it's almost like stealing your dad's or uncle's car and going for a joyride. And of course, he lost control of this sky chariot and wreaking havoc. He finally was stopped by Zeus. But in the meantime, he made a whole mess of what was the Milky Way. And this was the ancient Greeks' way of trying to understand and explain why the Milky Way wasn't consistently just this white band across the sky. Of course, later on, we had, still being on ancient Greeks, Aristotle and other philosophers like Anaxagoras and Democritus proposed that the Milky Way might be is the glow of stars, but they're not directly visible due to their shadow. And while other stars receive their light from the sun, so it was thought, they had their glow obscured by solar rays. So this is another way of explaining these discontinuities in the visibility of the band that we know now to be our galaxy. And of course, even Aristotle himself believed that the Milky Way was part of the Earth's upper atmosphere. And it wasn't until just shy of a millennium later, we started to see in the Byzantine era, Olympiodorus as an example, the younger, criticized this view because he thought that the Milky Way, if it were sublunary, in other words, below the moon and part of our atmosphere, then we should see parallax, which we don't see. So again, this is just on the cusp of starting to try and understand what was going on here in this band of sky. And I think it's important to kind of look back at our historical viewpoints, not only from a more primitive or Aboriginal cultures, but also even what we consider, ancient civilizations that are really the foundation of Western culture in many ways. Of course, I apologize to those of the Islamic backgrounds because there was a profound contribution to ancient Islamic astronomers, and even during what were thought of as I guess you could call it the Dark Ages. They retained a lot of the Platonian and ancient Greek writings that were lost in some cases during the fall of Rome. And it allowed during a lot of trade and so on throughout the Silk Road to have this information passed on to the early modern era. And of course, it laid the foundation for what happened further. So I apologize. It's just that there's so many of them that had varying contributions that it's just, like I said, that would be a talk on its own right. And I apologize to those folks that come from that background because I have to make a footnote here just to make sure they understand that. But certainly once we get to the early modern era in Europe especially, of course, Galileo and William Herschel are well known. And of course, Immanuel Kant, for those of you that take philosophy, may have heard of Kant, some of Kant's treatises. But Galileo was really one of the first astronomers, especially at the advent of the invention of the telescope, to look at the night sky. And of course, we know his contributions as far as looking at Jupiter and the moon. But certainly, even just turning it to the Milky Way, you can resolve very easily. And those of you who have, let's say, 10 by 50 or even 7 by 50 binoculars, you can see that the Milky Way is replete with thousands and thousands of stars. And of course, Galileo was also able to see this kind of structure within the galaxy as well. And of course, future investigations built upon this, of course. In a treatise in 1755, about a little over a century later, Immanuel Kant, drawing on earlier work by Thomas Wright, which I'll talk about next, speculated correctly, along with Thomas Wright, that the Milky Way might be a rotating body of a huge number of stars. You've got to remember that maybe about just a little over 50 years earlier, Newton had his theories of gravity published. And of course, it took the scientific and natural philosophy world by storm. So of course, they had gravity on the mind, of course, which is fine because we know this is true. but he believed that they were held together by gravitational forces akin to the solar system, but on much larger scales. And of course, later on, Kant borrowed on Wright's commentary about extragalactic nebulae as island universes, and they may be actually collections of stars in their own right. So just a little bit about Thomas Wright, because I think this is a very pivotal point in astronomy that often gets overlooked. You know, we hear about Galileo and Newton and so on, but this gentleman here started out being an instrument maker in England. And in those days, of course, especially specialty sextants and chronometers were instrumental in being able to more accurately map the globe. And of course, this is just right on the cusp of a couple of decades before Captain Cook's voyages. It was really instrumental to be able to have accurate chronometers to be able to do longitude measurements. So it's no wonder that when he started to teach mathematics and navigation at Sunderland College, it's a natural progression because it's intimately tied with astronomy. Sextants, you need to look at you do your latitude looking at the sun at a certain time and the altitude above the horizon, as well as navigating with the stars. So it's intimately connected with that endeavor. So later on in the mid 18th century, of course, he published his treatise on island universes. And he was the first person that I know of, unless somebody can correct me here, to speculate that the Milky Way was a flat disk of stars and that other distant nebulae and galaxies in their own right, as he called island universes, which Kant borrowed in his talk, was really, it took almost 3 centuries later for Hubble to be able to definitively hammer this down. This is an amazing development when you think about it, because it's, whether you call it gifted insight or he did a thought experiment, it's almost as profound as some of the thought experiments, in my mind, some of the thought experiments that Einstein did on the nature of light, because it takes a very out-of-the-box thinker, if you will, or a very creative person to be able to realize that this might be the case. Anyway, it did highly influence Kant's work on natural history and so on. But this is sort of the dawn of us starting to understand the nature of our galaxy, and I think it's really important. When we look at William Herschel, of course, he was trying to, of Uranus discovery fame, for those of you that have forgotten his name, William Herschel, of course, tried to map the Milky Way a little bit. And of course, you can see the central dot in the middle here, which is still, we're still thinking geocentrically, of course. But you can see some breaks in the stars to the left-hand side. This image is actually flipped 180 degrees from the original work, but I just found this diagram. I didn't want to flip it around. We're, again, trying to understand where the stars are. And at this point, these, I guess you could call it gaps in the stars as what they were thought of. These dark nebulae were really gaps in the galaxy at this point, and very little was understood. And even though there were investigations further, it wasn't until the advent of things like spectroscopy and photography where we saw a lot more work done on it. Of course, I'm jumping ahead a little bit here, but I think it's important to not go down too far a rabbit hole. Once photographic plates became sufficiently sensitive and resolution was good on the cameras, of course, you have Dr. Bernard here. Of course, he also did a lot of studies on some of the nearer stars to our own. And of course, Bernard's star being the when they were looking at him and Dr. Wolf studied a lot of closer up red dwarf type stars that had high proper motion. But besides that, Dr. Bernard decided to couple his camera to the 40-inch Yerkes Observatory instrument. And during this period, he took a series of photographs of the Milky Way. And this is really where we started to pin down what these dark regions were. And it took a little while to do so. His niece, Mary Calvert, was instrumental as his assistant and computer. And again, another contribution of ladies in astronomy. One of the things that was really interesting about his catalog, it took a little while. And in fact, he passed away before all of his work was fully published. And his niece carried it on with Edwin B. Frost, the director of Yerkes Observatory. There are also other dark nebulae that he captured in his photographic plates that weren't fully cataloged before other investigators started to take over and put them in their catalogs. So it ended up limiting with about a 370, not unlike the Messier objects, but a little different story in the background. But even Bernard himself, when he was looking at these plates, he wasn't entirely convinced right off that this was obscuring matter, or whether it was just a change in structure of the galaxy. It was really not understood very well. And it wasn't until he did some more visual investigations as a follow-up to some of these photographic regions that he was cataloging, that he was more and more convinced this was obscuring matter, and that these dark nebulae that now bear his name actually are opaque material within our galaxy. Okay, so it's kind of an interesting story there. I'll get into future contributors in a moment, but as an example, on the left-hand side here, we have an example of a plate taken from Bernard, and you can see these smudges and tendrils and everything. I mean, there was a lot of really interesting substructure to the galaxy. Hello? Can everybody hear me okay? I'm getting garbled talk. Am I?
I'm
Yeah,
not
we
sure
can
it's
hear you.
Okay,
There's some
sorry.
garbled, but we can hear you.
Okay, sorry guys. I just heard a comment, and I wasn't sure if that was me having bad bandwidth or something. My apologies. Okay, so you can see here how even on these plates, I mean, these are all monochrome, so you're just basically taking the luminosity here. But there's the Milky Way is replete with all of these substructures, and of course, very interesting things to look at. I've got an example on the right-hand side, and I'll talk a little bit more very briefly on Bernard 68. This is a region in Ophiuchus, and later on, some of these objects became known as Bok globules, and I'll talk a little bit about that shortly. Of course, for those of you that have had a chance to look at the region around Aquila, just offside of Terra-Z, this is the bright star to the immediate left of this E-shaped nebula known as Bernard 142, 143, by the way. This is known as Bernard's E. Those of you that have looked at this either in a wide field telescope or a pair of binoculars from a dark site, very interesting little object to see, and it's just one of many that you can see, and you may have passed by it and not even given it a second thought. That's kind of cool, and then moved on. So I just wanted to point that out, that these things are dotted all over the Milky Way region. So I'm going to flip forward for a moment, and then I'll get back to Dr. Bok here. But this is an example of an ESO multi-image rendering of the galaxy, and you can see here in this high-resolution photo. I mean, we have the LMC and SMC, the Magellanic Clouds to the slightly below right, kind of central below right. You can see the core of the galaxy, and you can see all this dark material all throughout the region of the galaxy here. Certainly even better than we see it here from Earth. But this is really interesting when you think about how much material we're actually looking at here. And like I said, the sky is replete with this. If we look at the Gaia stuff from space, of course, the CDR3 data, the center of the galaxy is over here, our galactic core. I know Danielle mentioned about the new innovations that have just recently come about trying to understand the black hole in the center of our galaxy. But we have to use other wavelengths in order to penetrate this dark material, okay? And that's one of the nice things with some of the more modern tools, is using multi-wavelength imaging allows us to penetrate these dark regions that are basically optically opaque. Pardon me. So if you look at the upper right here, you can see some of the constellations along the band of the Milky Way, and we have Capella, and you can see this is just sort of a schematic of some of the larger scale clouds and substructures that obscure what's behind them. And moving all throughout, going towards the middle, we have Deneb, which is of course in Cygnus, the tail of the swan, and you can see the summer triangle, of course, and I'll feature a lot about this later when we talk about what to look for. And then, of course, you go through Aquila and into the inner arm clouds. And then, of course, moving down to the lower left, we have Antares and Scorpio. And of course, once we go to probably from the central left all the way to just about the central right, that's below our horizon, being here in the northern hemisphere. And then, of course, we start getting into Sirius and Betelgeuse and Procyon and so on and moving over. So this is what we're talking about. And I thought the schematic diagram was kind of neat to show what these structures and where they're found all throughout the region. So really, at any time of the year, there's always some chunk of this that's visible. Now, when we look at our place in the galaxy, thanks to people like Thomas Wright and others, of course, here's our sun, and what we know to be the Orion Spur here, kind of a substructure, kind of bridging between the Perseus and Sagittarius arms in our galaxy. And to the right, of course, we have our kind of a top-down schematic of the galaxy. I'll blow that up for a moment. And you can see how we're sitting kind of right in a region sort of proximal, but also in between two core spiral arms. And I apologize for the resolution on this. It's the best I could find on this one. But you can see how a lot of the Milky Way constellations where we see bands of the Milky Way are all dotted all throughout this whole region. And the sun is, of course, centered in this one. And it's no wonder why we see a lot of this dust and gas, because even as we look at the schematic, there's a lot of voids and so on. And even the discontinuity that we see as we go, towards in between the Sagittarius and Perseus arm, we actually see less and less dark material there compared to when we go through the Sagittarius region. So just wanted to point that out. So that's sort of an overview of, like I said, our place in the galaxy and so on. I'm just going to talk briefly about Dr. Bach, and then we'll go from there. But just prior to that, I just want to talk about what these dark nebulae really are. And again, I could go down an entire astrophysics rabbit hole, and that's a talk unto itself, but I'm going to brush on this a little bit here. So these are known to be now, in the modern era, regions of interstellar gas and dust. And of course, I've already talked about them being optically opaque at visible wavelengths. Now that we've done multi-wavelength imaging, we can actually penetrate into the infrared, near-infrared, multi-millimeter wavelengths, of course, penetrate very well, and even some of the radio wavelengths. And so we're actually able to understand these a lot more than we did just doing optically. But these are really effectively galactic recycle bins. If you can imagine this material, the early part of our galaxy, we would have had star formation with much larger stars that lived fast and furious and then exploded. And of course, being stellar nurseries in a way for future stars, I mean, there was a tremendous amount of energy released during these explosions. And we also had nucleosynthesis. So we start seeing these molecular clouds, not only in the bright ones that sometimes are affiliated with these dark nebulae, but also the more isolated ones. We have clouds of gas and dust, and it's not just carbon and other materials like carbon. We also see silicates, polyaromatic hydrocarbons, and a wealth of even ionic species. And I'm just touching on a few here, plus water, of course, too. But still the vast majority of the material is still hydrogen and helium. However, these are very interesting because if you look at, even when we look at our Oort cloud and a lot of the cometary materials that come in our solar system, we start seeing things like amide structures and precursors to prebiotic material. And again, with the Bach globules, Dr. Bach was one of the first to conjecture that these are not only stellar nurseries, but the birth of solar systems in their own right. Before I get to Dr. Bach, though, I just wanted to show you this image here. And for those of you that have done astroimaging before, I'm sure you've seen this. This is obviously a very high resolution image that would be the envy of any budding astrophotographer. But this region here, not too long ago, there was a group out of Italy that actually did some work at the 30 millimeter IRAM telescope. And you can see some of the signatures here. These are in the gigahertz range, and this is more into the deep infrared and even millimeter wavelengths in some cases. I didn't do the calculation between gigahertz and so on, so I apologize, but I believe it's in the mid infrared. But you can see a lot of species are identified. We have everything from like hydrogen cyanide, we have ionic species, we have amines and so on, and even carbon-carbon bonds forming in these structures. Carbon sulfide species, they're more molecular ionic, what we call radicals in chemistry, but they're very stable because the gases are very diffuse, and therefore they don't interact as readily, and it takes a while for this chemistry to develop. But these are basically the building blocks of a lot of the biosignature molecules that we're now looking at in exoplanetary surveys and so on. So it's no wonder that we start to see these things, and this is sort of tying a lot together. And as Danielle mentioned earlier, this is really exciting times for astronomy, because now that we have the tools to look at this in more detail, we're really starting to see where we might be coming from in ways. And with the advent of now the high resolution with James Webb, I'm sure penetrating into these regions further, I'm sure we're going to learn a lot. All right, so just before I get to Dr. Bach, I just wanted to show that, as we dig deeper and deeper into higher sensitivity and resolution and wider fields, you can see the pipe disappears, and there's all the substructure throughout here. And this is actually intragalactic dust and very, very small nanoparticulates and ices and everything, but it still is optically opaque. And we're looking at the back side of it, and we'll talk a little bit more about that later. But this is known as Bernard 59 complex, by the way, for those of you that are curious. Part of the Pipe Nebula complex. This was taken with the ESO 2.2 millimeter telescope at La Silla in Spain. Okay, so let me just flip forward. So I want to talk about Dr. Bach just for a moment, because he built on a lot of the work that was done. He was basically in his school years when Bernard was collecting the data and it was getting published. So it was a foundation for some of his work. And he's best known for work on the structure and evolution of our Milky Way galaxy, discovery of what I call Bach globules that now bear his name. They're small, densely packed dark clouds of interstellar gas, not always by themselves. They're also silhouetted against brighter backgrounds. And as I mentioned earlier, he's one of the first to suggest that these may be in the process of contracting and forming into new stars, and may be integral in the formation and affiliation with stellar nurseries. He started his career looking through the Anglo-Australian telescope. And of course, he studied a lot of the southern hemisphere's goodies, like Eta Carinae, that we don't get to see in the northern hemisphere. Is replete with dark structures all throughout, as well as highly energetic emission nebulae. And then, of course, LH95, which is a dark nebula in, or a feature in the Large Magellanic Cloud, which is one of our satellite galaxies. So again, a lot of these studies led him to the understanding that these may be, there's a lot more going on, and there may be seeds to future solar systems. This one here, Bernard 68, that I showed earlier, is known as a Bach globule as well. It's also the closest Bach globule to our solar system, about 410 light years away. I left the stellar coordinates for those that want to jot it down in case they want to check it out, maybe with one of their big guns or plug it into their go-to scope. But it's the closest one we know to date. It's estimated to be about 0.2 light years across. So when we were talking about some of the structures earlier, this is a very tiny one comparatively. It's about two solar masses of material, which is enough theoretically to form a solar system not too different from our own, assuming the conditions are right. But if you look at this structure here, it's no wonder why before we had the advent of better imaging and so on, and even going into different wavelengths, optically you look at this and it's really hard to tell whether or not this is actually somebody just taking a magic marker and erasing the stars in the middle. It's kind of kidney shaped, or if it is indeed like some sort of gap in the star field. Just even when you look at the surrounding there, it almost just looks like all of a sudden the star stopped. And it's no wonder why it took a little while to kind of get to the bottom of this. Really interesting stuff, I think. I hope you're following along and appreciate it as well. Oh, one other thing, the temperatures of some of these are some of the coldest in our galaxy, mainly because we're looking at the backside. So even if there's energy and star, like UV and visible and thermal energy hitting this from what we can't see, I guess you could say on the backside or the far side, We're seeing it on the front, not unlike when we get close to a new moon. And of course, the temperature here being in this one, 16 Kelvin, is not too far above the microwave background temperature, 3K. I mean, yeah, there's a bit of a gap there astronomically, but it's just interesting to think that these are some of the coldest, darkest regions in the in our galaxy and in the universe collectively. So when we look at some of these interstellar clouds, you can see in this image here from Spritzer, we're seeing not only molecular hydrogen from the emission, but we also see PAH. For those that that don't know, chemistry is polyaromatic hydrocarbons. So things like naphthalene, anthracene, and so on. These are basically 6-membered rings interlinked, and with 5-membered rings, they're usually quite planar, but they have very complex structures. And normally we see this would be the char that you find in your barbecue, basically. So when you think about how cold these regions are in some cases, it's amazing that these structures form at all. But these are the building blocks to a lot of complex carbon chemistry that we see in biospheres that we know on our planet. And again, like I said, there's a lot of speculation as to what might be happening, and it's starting to tie a ribbon around the exoplanet formation and everything. So this is really neat. Silicates are shown as well, and even neon that we know as trace element in our atmosphere. Again, we also see neon signatures in a lot of stars as well. So, I just wanted to mention one other thing. Quite often the stars that are forming on the back ends of these nebulae are occluded from our view unless we use a different wavelength. That's very important. There's 2 theories for spontaneous and triggered star formation. One is where the molecules, just because of the motion within, it could even be another star passes by and gravitationally perturbs these regions. It becomes unstable and starts to develop a spin, and then eventually it collects into what we think will be a proto-stellar system. Triggered star formation, some of these, because they're in very active regions in the galaxy, could be unstable and perturbed because of huge electromagnetic forces like a supernova proximal to it. And if that's the case, then they would also start to perturb and eventually collapse into stars as well. So kind of an interesting theory, and I'm hoping that we'll start to see a lot more information as we investigate further, especially with tools like James Webb. This is a shot with an infrared versus visible shot of the Teresium cluster, and those of you that have done stellar imaging before are very familiar with this region in Orion. But you can see the difference when you start getting very outside of our atmosphere, and you look at the image from the Wide Field Planetary Camera 2. The stars hardly show at all. There's just so much nebulosity around them. And then, of course, as we go to the infrared, there still is a lot of structure there, but now the stars pop out really well. And this lends to the credence that a lot of this nebulosity includes some star-forming regions. Okay, so I'll leave it at that for the moment, other than just a couple of little graphics just to show that as these collapse, this is kind of what's thought is happening. And of course, there's a lot of work to be done in extrasolar planetary surveys yet too. But as these gas and dust groups collect, then we start seeing the dawn of planetary systems, and pretty exciting stuff. It's starting to tie it all in. So having said that, we'll get to the good stuff now. And thank you, Emperor Palpatine, for that lead in. So let's talk about observing these. And of course, some of the stuff I talk about visual observing these nebulae will also apply to those of you that want to do astro imaging as well. There's a strong correlation between the two in this case. So dark nebulae vary in how much they obscure the background stars. Of course, as you've seen, you can have things that look very, very black. And in some cases on those multi images that I showed, you have varying degrees of darkness, right? Now, one of the investigators, Lind and her group, looked at an opacity scale, and they actually used Mount Palomar data. They used the extremes of the visual spectrum to shoot photographic plates rather than full spectrum visible light. And of course, by comparing the two, they could determine, at least visually, how opaque these things would be. And it's been done on a 1 to 6 scale, the most opaque being number 6, and of course, the least opaque being number 1 of these dark nebulae that you see. And there's an example here of what would be, I guess, considered samples of Bernard galaxies, or sorry, Bernard dark nebulae that would have varying opacities or darkness levels to them. Now it's very important, I'm just going to take a sidebar here. Those of you that use Stellarium or use another program that shows opacity, you'll see a number, and it's usually from 1 to 6, and that's what that number means. That's basically why I wanted to introduce you to that. This one here is the Northern Coalsack Nebula, and it's right by, not too far, it's between Cedar and Deneb in the constellation of Cygnus, or near the Northern Cross, for those of you that want to use vernacular. And you can see easily here, this is quite a large feature, but of course, it's sort of considered mid-opaque. Now, if I go to something like this particular Bernard dark nebula, it's a lot smaller. You can see it's only, barely a 1/6 of a degree. And of course, we still have the opacity. It's a bit more opaque, but of course, it's a lot smaller. Depending on the background, this has a huge impact on how visible these structures are. Obviously, astrophotography, when you're using astrophotography, you can, do a longer exposure to pull these out a little easier. With visual observing, of course, that isn't always the case. I'll talk a little bit more about some tricks that you can do to help your cause a little bit. When you're wanting to look at dark nebulae, this is one of them, the LDN, or the Linz Dark Nebulae. That's sort of an extension to some of the Bernard catalog, I guess if you want to call it that, or an alternate catalog. I've checked off the Bernards here, and you'll see if you do a search for any of the Bernard nebulae that I showed already, you have to have that checked off in order to show. And as you can see on the screen, these show up as a gray square, kind of a dark gray square, versus the green square of any of the nebulae that you have, or of course the circle within a kind of a plus for planetary nebulae. So that's where you'd be looking for these things in Stellarium. So what you need to find these are very, very dark skies. Ideally, the darker the better, but even moderately dark skies can still show a lot of dark nebulosity. And those of you who have even gone camping out, I mean, some of the larger structures like the Great Rift along the underside of Cygnus there, on the side of Cygnus, show up naked eye. And even the Northern Coalsack and just proximal to the North American nebulae, beautiful to look at in the night sky. But ideally, very good transparency is essential. So the clearer the air, the better. Of course, last year we had our butts kicked very hard with forest fire smoke and other things. So it was almost impossible to see these things until the latter part of the summer. I did get an opportunity end of September. I was up at Grand Marais and was able to see some of these very nicely, but it was a narrow window. And after that, when then we got to cold weather, and it just kind of wasn't much fun anymore. Best instruments to use are rich field telescopes, not necessarily exclusively, but it certainly helps your cause. Generally, wider field instruments really help to pull these out, other than some of the more isolated regions like the Bok globules, which are a lot smaller. Certainly a larger aperture instrument will certainly help your cause, but you don't want to go to extreme power in this case. You'd want to go to a kind of a moderate power, because otherwise you start losing the object. I'll talk a little bit about that in a moment, but of course I have to put a plug in for binoculars, because they're some of the best instruments to use for these. Not only because you have the 2-eye view, but also because of their wide field capability, and quite often their portability makes it really nice to be able to pan around the sky. And the idea here is also to minimize any light scatter and improve contrast by keeping clean optics. Try to keep yourself using as low a setting as you can on your red dot, or on your red light when you're reading your sky charts, because you need every available sensitive rod to be able to pull these out sometimes in some extreme cases. Most of the objects, not all of them, but many are in the 5-degree range. Some are smaller, some are larger, depending on where you're looking. And again, a 5.5 Nelm or beyond is ideal for viewing these things. Those of you that want to do wide field astrophotography, I'm not going to necessarily suggest a certain lens or exposure combination, but I would think at least a minimum of a minute or so per per shot would help you out a lot. Certainly if you can get to 5 and 10 minutes, in some extreme cases, you can pull out the really heavy structure. Some of the best regions are Cepheus to Cygnus, of course, Cygnus to Aquila, I already talked about earlier a little bit on that diagram that I had those clouds showing. Scutum to Sagittarius is a very well-known region. Of course, Jerry, I'll second again Sylvia's commentary that Jerry does a fantastic talk at the Star Party, and he talks about a lot of this stuff that you get to see, mostly featured on the Messiers and some of the more interesting regions in the galactic structure just above the core. The southern Milky Way goes all the way across, but he does feature some of the dark nebulae as well a little bit, and so it's very interesting. So definitely take your time to attend that because it's very, very educational. He knows a lot of stuff. Fall to winter, of course, you can get into Perseus and Orion and Taurus, and there's large clouds in Taurus and Perseus that aren't always as obvious, but if you get, obviously when we get into fall and winter, the skies are a lot darker and the air is usually a lot clearer. So if you can get out into the country and brave the elements, you're in for a treat. And then of course, as we get into this time, spring into summer, Ophiuchus is a great one. We're kind of losing our window right now, going into early summer and right proximal to the solstice, because we're starting to lose our astronomical twilight windows, of course. This is a slide taken off of the Astronomy League website. They actually have a dark nebula program, and I thought I'd borrow it here. And it shows you some of them are named with common names, and the other ones have their Bernard's nebulae or LDN designation in some cases. Le Gentil is LG as an example. I have a diagram here in a moment. This shows you the kind of nature of the object, whether it's naked eye and binocular, or binocular and telescope. And again, it'll depend on the particulars of the size and the region that you're in, whether or not you can actually see it with one or the other or both. If you have larger binoculars, I mean, that would substitute in some cases a telescopic view, but not necessarily exclusively. And of course, they have the different star atlases that are well known, the Millennium Star Atlas, or if you have either edition of Uraniometria or even the, so it's kind of nice. You can refer to those sky charts and find them. And this is, so this is about somewhere around 2.5 or 3 dozen objects. And again, it's a really nice way to cut your teeth into some of these, because some of these are quite easy objects to see. And you may have already seen them before panning around and didn't even know what you were looking at. So that's just another reason why I think a talk like this is nice, because these are really challenging objects, but they're very interesting and they're an intimate part of our Milky Way, as I say. So I'll finish off by just going over a few areas of the sky, kind of as we get into spring and summer. And as you can see here, this is Cepheus. So you've got Mu Cephei, one of the darkest, reddest stars in the northern hemisphere. And you can see some of the, this is just a smattering here of a couple of Bernard dark nebulae. And of course, you can get a kind of a flavor for, there are some that look darker than others. And it also depends on what's around them too, as to how well they show up. So it's not just exclusively the opacity that helps you find these things. It's also the surroundings, because obviously the Horsehead Nebula, you've got an emission nebula. It's a bit of a challenge to see with smaller apertures, of course, but you do have that high contrast, and the fact that it's illuminated from behind makes it a lot easier to see. When we're looking at star fields like this, it can be quite a challenge. I've got several views of, I apologize for this one, it's not the greatest one. I've got some better views of Cygnus, but this just shows Le Gentil 3 or LG3 that was on that other diagram, right proximal to M39. And of course, just below M39, we have Bernard 168. And of course, you can see it kind of as a gap in stars here. Of course, as we look towards like this L935 here, this is basically right around the northern coal sack. And of course, right immediately beside it, we have the North American Nebula. There's also a handful of other ones here. Better diagram is here. So here's the northern coal sack here. And of course, we see the Cygnus star cloud in between Saturn and Nibiru, and the Great Rift is actually below it. And I've got a better diagram here. So we're starting to go move towards as we get into later summer. This is really, really nice and easy to see. Of course, the summer triangle here, features very prominently overhead midsummer. So as we get out of the solstice window, this whole region just comes to life, and especially the star party too. It's right overhead and it's beautiful to look at. And this Great Rift is very visible when we have a good night out at the star party there. And of course, Altair going down further towards the south and into, I guess you can, in this case, lower left. I'm just going to pass on here. Just be mindful of where Altair is. We now have Altair here. This B142 and 143 is Bernard Z. There's Terra Z, Gamma Aquili. And of course, this whole area too. This is the Great Rift, of course, going along here. We have all sorts of really nice nebulae all throughout this region. You know, and this is just a various because there's a whole bunch in here. Make a note here of M11 and Lambda, because when I go further south, that's Bernard Z region. And you can find that in a binocular field. And a decent pair of binoculars will show that from a moderately dark site. It will pop out, like I say, about 5.5 and beyond. Nelm would be just adequate for being able to see this, as long as the transparency is good. So as we go to Lambda Aquili, and there's M11 here, whole bunch of other ones just all on around here. So like I say, these are a lot of fun. Some are easier to find than others. And those of you that want to do photography like this, I would probably use a telephoto lens that's fairly fast, because obviously you're not taking in the whole Milky Way. In that case, you're taking an isolated section. As we go further south, of course, this is a more expanded wide field view. We go further down, and then of course Jerry talks a lot about, you know, the Sagittarius star cloud, Swan Nebula, Eagle Nebula. There's a whole range of other DSOs in this region, but certainly when we look at the structure of the Milky Way, we have some clouds here. Even though they're not very opaque, they do show up well in photographs if you take the time to do it properly. There's M25 here, the small Sagittarius star cloud here. Here's an example of two nebulae, B92 and B93, that one is very opaque and the other one isn't as opaque. But because of the star region around it, it's very obvious that you can find B92 a lot easier. And it's no wonder why sometimes when we're visually looking at some of these are very, very obscure. Sidebar here, I was just going to mention that Sylvia enjoys sketching. This is a real challenge for sketchers as well. I have a link to Mel Bartel's website here shortly. This is some sources for information on dark nebulae. I mentioned Astro League already. This is their dark nebulae club. And the first set of slides that I showed you with the objects there is part of that. I have a link to it below. Also, Mel Bartel's has a really nice website here on looking at and sketching dark nebulae. And Brit Astro also has a dark sky challenge with dark nebulae for the summer, and so does Sky and Telescope. Just another side comment here before we close off. If you want to look through the RASC handbook this year, page 321, Paul Gray has a great selected targets of 31 dark nebulae, and he talks a little bit about that it's just on one page, but it's definitely an interesting read, and it would be a good place to cut your teeth on a quick one if you don't have access to a computer or you're out in the field and want to remind yourself. Bring the book along so you can refer to it. Georgia Tech has a website with links to the original E. Bernard plates, and you can actually search by nebular type. And so I thought I'd include that because those of you that like historical information on astrophotography might find it very interesting. And it's very, very nice to look at these kind of things and kind of get a feel for how far we've come in the last few decades. Again, I just wanted to reemphasize the Astro League Dark Nebulae Observing Program. They have the required objects and then the optional. The optional is about 3 times more objects than you see in the required ones. So those of you that really want to have a challenge and really dig into this hard, I recommend both of those. They have PDF files that you can download, and it'll give you some countless hours of challenges for sure. So having said that, I hope now you're a servant to the dark side and have tintillated your curiosity, and maybe we'll see some people post observational and other reports, and maybe even some astro photos of some interesting dark nebulae that they might discover as a result of this. So thank you very much, and welcome to the dark side of astronomy. Any questions?
Oh, hi, Darren. I'm James Perch.
Yeah, hi, James. I've met you before. How are you tonight?
Good. I'm just wondering about the dark regions. Could it be related, like formation of the universe right after the Big Bang? Like there would be, I heard a theory about bubbles of.
Well, I don't know if I can answer. You're talking, yeah, but see, you got to remember there's a long time between the Big Bang and then our galaxy, and some of this matter may be left over from the Big Bang. I think we're going to learn a lot more with some of our new tools over the next decades, James Webb being one of them, as well as looking deeper towards the more distant galaxies in the infrared may shed some light on that. I can't really speak to that. I'm not an astrophysicist. I'm a chemist by trade. But having said that, it's a very interesting comment. I do know that a lot of these dark regions, I guess you can almost think of them as celestial recycle bins, because the universe is a very efficient at using not only energy, but recycling matter as well. And so that's kind of why I was alluding to the nature of these. As we discover more and more, we're seeing these types of regions. I think we're affiliated a lot with maybe Danielle can maybe comment on this a little bit and help me out. But the supposition is that, early on in the early part of our galaxy, of course, there was multiple interactions and so on. But as our galaxy formed, of course, we had mostly hydrogen and helium. A lot of these stars were very large, very energetic, and then exploded in supernova explosions. And of course, during nucleosynthesis, you've got all this material that eventually has to collect and regroup. And so we're already into the third, fourth generation stellar formation now, or maybe even more in some cases. So I think these pockets of clouds allude to that kind of thing. We're recycling these heavier elements, and it's leading to more complex structures. Does that help a bit?
Yeah, thanks. I mean, yeah, it's a big help. And yeah, may the force be with you.
Thank you. Also with you.
Yeah, I'm a big Star Wars fan. I got my Darth Vader figure in the den window, plus a stormtrooper.
There you go. Awesome.
But
Any
yeah,
other questions tonight?
thanks, Darren.
You're welcome, James. Thanks.
So Darren, there's one request in the chat there.
Let me just open it up here now. I
Yeah,
didn't want to open it while I was talking because then it blocks my stuff.
Yeah.
Oh, thank you guys. Okay,
So
can
the
someone post the Georgia Tech link here in the chat? I can do that later if you, or maybe I can do that now. Just a minute here. I'll post that in a few seconds as you're doing closing comments there.
Sure.
Unless somebody wants to do that on my behalf, I appreciate that. If you could do that, just copy paste. Might be a little harder for me on my PowerPoint actually, to be honest, but maybe they can do a screen capture. If somebody wants, I could maybe even send it to Michelle Boyce and she can post it on the Facebook site. Would that work for everybody? The Georgia Tech link? That'd be a good idea.
Yes, that'd be great.
Okay, we'll do.
I'll
Send that to Michelle because I know she's very prolific on Facebook. I'm not on her Facebook site, but I'll send her an email with the link and then she can post it onto the Facebook site for everybody, if that'll work for everyone. Great. I'll just backtrack these slides for just 2 seconds, just for the Georgia Tech website so that everybody can see it. Am I still sharing my screen? Yes, I am.
Yes, you are.
So I'll just leave it on there for a minute if somebody wants to just
Someone
jot
just
that down.
pasted a link.
Oh, did you? Okay, great. Thanks.
Yeah, someone just pasted it.
Awesome.
Robert.
Cool.
All right. So are there any other questions? Because if not, we'll
I have a question. Sorry.
Sure, Danielle.
Yeah, go ahead.
So Darren, you showed some images with spectroscopy images.
Yeah, I can roll that back here. Just let me go back here.
Spectroscopy. I'm sorry if you've already mentioned this, but do we have a sense of the motion of these things? Are they fairly static? Or,
Excuse me. Do you know that's a really, in other words, like, are there Doppler studies on this?
Mm-hmm.
Yeah, that's a good question. I don't know the answer to that. Like I say, I think there's a lot of, with this high resolution spectroscopy that's being done over multiple wavelengths, I think it's still a little bit in its infancy. We're discovering these molecules and ionic species. And I think the resolution is kind of getting to the point, not unlike what we're seeing with some of the Doppler studies on exoplanets, where they're starting to be able to actually detect these small motions. So I think in the next couple of years, we'll probably have a little bit more information to be able to do. So that's going to be my kind of cop-out answer. I apologize,
No,
but
it's okay.
I think it's valid because we're learning. I mean, the same instrument, the same kind of technology that's being used to do Doppler studies on stars, looking at exoplanets and so on, and doing Doppler studies there is applicable to this kind of spectroscopy as well, right? Where we're looking at shifts and so on. So I think we're going to learn a lot more in the subsequent next 10 years. I think it's going to be a huge explosion of information. We'll have a much better pin on this. But even just looking at this, just even looking at this, how do I get back here? Even just looking at this one, you can see how there's different moieties here. And even this one's a lot noisier too. You'll notice on the bottom here, this region here,
Oh yeah.
there's a lot more background noise here. So these the spectra is, you're getting strong signals, but there's probably stuff lost in here versus this region here. I mean, you got much cleaner signal, and look at the signal to noise ratio. So maybe even there might even be some, things to discover there too. So
It's infrared.
exciting times, like you said earlier. I think astrophysics and just learning about the dynamics of our galaxy and spreading it to other galaxies, looking at being able to actually get this kind of information even from extragalactic sources, even closer to, within our local group and so on, is going to be really exciting times, I think.
Is this infrared?
This one I think is, I didn't do the calculation. I think these are infrared signals, kind of mid-infrared. I'd have to do the math on it. I could be wrong. Danielle, do you know the conversion?
I'm not great at those conversions on the fly.
Yeah, I'll have to double check this. I'll let Michelle know that too, and she can just pass that on. I mean, I could do a quick calculation, but I think, this would be actually, let's see here,
look like
gigahertz range here, right? So that's billions of hertz. I don't know. I think we're kind of trying to remember what the optical wavelengths are, aren't they? Around 60. So this could be, it should be infrared. Should be kind of
It looks infrared just looking at some of the chemicals.
Yeah, I'm thinking it is.
But I believe there's plans to have an infrared version of Gaia, so that would really provide a lot of extra data.
And if they couple that with the James Webb stuff, that'll be very interesting. So like I said, there's a lot of new tools just about to be released here in this next decade that's we're going to see in the next 10, 15 years an explosion of information that's going to really help us pin down a lot of this astrophysics.
There's some cool stuff coming. James Webb should be taking imaging next couple of months or so.
Yeah.
Cool.
And then coupled with some good spectra too, that's going to be awesome. So like I say, this is exciting times. This should be in the infrared. Oh yeah, see, look, if you look at the top one here, this is the near infrared here, and then down below is kind of in the mid infrared. So there's two.
Yeah.
This is kind of a collapsed spectra here. Yeah. So, and they show the temperature in Kelvin here too, converted. So kind of interesting. You can see how dark it is here. It's dark.
Yeah, this is such a dark talk. I don't know.
Yeah, you betcha. So I thought dark side was an appropriate topic talk for it. But I'm glad you guys enjoyed it. Any other questions before I close out?
I have a question, if you can hear me.
Sure, yeah, you bet. Ed.
Yeah, this is probably more of a layperson type question, and hopefully you didn't cover this already. Do you have any, are there any theories about the origin of these dark nebulae? Are these the result of dead stars? Instead of having.
Well, that's exactly. Yeah, you're kind of asking, kind of re-asking what James and even Danielle and Michelle and I were talking, but don't worry about it. This is a bit of a mystery. The supposition is that a lot of this is material that's been recycled from supernovae explosion in the earlier evolution of our galaxy, but not exclusively. Also, interaction of earlier galaxies with ours stirs up the gas a bit and material, and then it collects. But this is the thought that a lot of this extra or intragalactic dust is the kind of I guess you call it the ashes of earlier stars and stellar systems, and now it's being recycled into new stars. And in some cases it's affiliated with higher energy regions, and in some cases it's more isolated than that, and that's why it sticks around a little longer. Does that help? Am I wrong, Danielle, or is that pretty close to the modern theory? I'm not an astrophysicist, but I think I got it hammered okay.
Yeah, I think that's the current understanding.
Thanks for your backup. Appreciate it. Yeah.
Oh, hi. Hi, Dan.
Thank you.
Hi, Darren. Sorry. I just had a thought. I read about dark flow quite a while ago. Does that have anything to do with the movement? Say there's movement with these dark regions?
Well, in the some earlier slides that I had, let me see if I can go back one or two here. I think I had I was talking about what yeah, I think it was further back here. Just a minute. Let me just see where I found it. Well, see, like this theory of spontaneous versus triggered star formation. This is sort of tied in, if I understand your question correctly, dark flow. A lot of these tenuous regions of dark material being so cold, in some cases where they're more isolated, you're not going to have a lot of energy exciting them. So they'll take a lot longer to collapse under their own and perturb under their own local environment. Whereas other regions where they're in more energetically areas of the galaxy, where you have things like electric and magnetic fields and gamma ray bursts and like a full-blown supernova explosion, which could, eventually create a shock wave that might perturb those regions, then you'll start to get spin and turning and perturbations enough for them to start to collapse under their own. But often, because we can't see how deep these are behind, because we're looking at the front of this, a lot of times when we're doing these or when astronomers are doing these imaging in other wavelengths, they can see the stars, like the trapezium is an example there. It's obscuring the stellar nursery to a certain extent, depending on how opaque these regions or how energetic they are. And of course, we can see the stars much more clearly here. So again, this dark flow, is that what you're talking about? Like these perturbations of these dark nebulae and how they start to coalesce and then form finally solar systems in their own right? Is that what you're alluding to?
Yes. Well,
okay.
Plus, I believe there's a flow. It's carrying stars, I think, from our galaxy in one direction.
So galactic rotation would drive some of that.
Like, here's the, well.
Or are you talking dark energy, dark matter influence on these?
Yeah, like,
I think that's what he's talking about.
Okay.
But it's dark currents, which aren't
dark currents.
dark.
Okay, yeah. I don't know enough about that to really speculate, but I'm sure some of the dynamical models that are affecting galaxy at large would certainly affect these regions too. There'd be no reason to think these would be exempt from that type of physics.
Yeah, and especially with supernovas, and I understand there's a terranova. There's even bigger star detonations, but yeah, dark flow. I heard that it's like going in one direction. I'm not exactly sure what direction, but
well, maybe it might be interesting if you feel like passing on some information, maybe put together a talk and maybe present that sometime. That sounds like pretty interesting material.
Yeah. So maybe what I'll do, Darren, is we'll close the meeting off now, and then conversations can continue on if that's okay.
Absolutely. Thanks,
okay.
Guys.
So again, everyone, thank you very much to Darren. Certainly from all the comments and that in the chat, very, very pleased with the talk tonight. Thank you again. So just a couple of quick announcements before I go. So first off, I'd just like to, for most of you probably don't know that, but Ed Wright, who is our Secretary of the Council, puts a lot of energy into putting these meetings together and making sure the presenters all have all their stuff in line, and he has copies and that. So I just want to formally thank Ed for all the work he does to set the meetings up, the Zoom meetings, as well as to get the notifications out to the membership. So thank you very much, Ed. The other thing in chat earlier.
Sorry.
Oh, you're most welcome, Ed. The other thing in the chat, there was some talk about green laser pointer training. It is scheduled for our next meeting, June 10th, and I will be delivering that training at that time. So anybody that's looking for it, that's the time to be there, and we'll present it on Zoom. So I worked with National to figure out a way that we can do this, meet all the intents of the agreement we have with Transport Canada for the training, as well as the use of the permit. So again, the green laser training will happen at the next meeting, June 10th. And with that, we're pretty much at the end of our meeting, and it will switch over to an open format for our virtual Boston Pizza. And I thank you all for coming tonight. We've had excellent speakers and excellent information on what's going on in our universe around us. And I thank you all for coming. And I'm going to be signing out though shortly. So I wish you all a very good night and have a good one.
Have a
Good night,
great,
all.
and may the force be with you.
Thanks, Dennis.